if it is equal to prod, I need to assign T3 large. Otherwise, I need to assign T2 micro for except to prod. If I'm using any other environment, then I have to use T2 micro only. Like that, I am configuring. So you can use conditions like this. You know what this code, this code will work is, if it is production, then it will use T3 large. If it is stage, then stage or any other environment apart from production, it will use T2 micro. Okay, this is how you can inject the conditional statements, conditional expressions. Next one is local values. Local values. I'll just check whether I have virtual keyboard. Local values. In local values, like the purpose of local values is, it will locals just like what it will do is, it will simply config by defining reusable expressions. Okay, like it simply configs by defining reusable expressions. Okay, if you use local values, so how you can inject like that, you can ask, right? So actually it is same like variables only. Like instead of using variable, we can use locals. Okay, that is not much difference. Just I will show you the example. Locals. In region, I'm just using AP South one, that is Mumbai region. A is not working. Okay, so while you are reviewing this, just use A some like, okay, if you are getting any doubts in the value T2 dot micro. Okay, now I'm just declaring my locals as T2 micro. What you can do is, just you can inject this instead of mentioning T2 micro on instance type, you can just mention local dot instance type. Okay, mostly we will not use locals. Okay, remember that we will not use this. We will use variables only. There is no use of using locals. Okay, since we have this in our syllabus as well as in Terraform concept, I'm just explaining you this. And while coming to instance type, I can call local, and I can tell local, and I can use instance. For that, I can directly use my instance value itself, right? So only we are not using locals. Okay. So next topic is Terraform functions. Terraform functions also we will not use. Okay. I'll just discuss Terraform functions. Okay. Ninth one is Terraform functions. Like the purpose of Terraform function is, which provides built-in functions for string manipulation, and as well as math, as well as type conversation, etc. Okay. The thing is, example is, for example, how you can use string manipulation is, for example, I need a allow in small letters. It's like a programming language. Okay, in Python program, we have lower, higher, upper, like that is we have, right, like that one here also. For example, I am giving input as lower allow. Okay, then Terraform, what it will do is it will provide output as hello in small letters. If you read in capital, then you have to use up. Okay, if you're providing length here, then it will count to each element and it will send you the output. Okay, this is the Terraform functions. Okay, 11th one is data source. Data source only, right? Local functions, local values, Terraform functions, data source. Yeah, correct. Data source. Unable to copy paste. Okay. Data functions. That is 11th one. Okay, while coming to data functions, what it will do is data source fetch data from external systems to use in Terraform configuration. That is the purpose of data function. Okay, what it will do, it will just use to fetch data from external systems to use in TF functions, in TF manufacture, TF like manifest file. Okay, the thing is, if I want to explain with an example, for example, consider what every time while we are creating instance, we will copy the AMI from AWS account and we will use that in our Terraform configuration. But you are not willing to copy paste. You want to fetch it automatically. Then you can use data source. What it will do, you have to provide details like who is the owner of that image. Amazon is the owner, and I need a Amazon Linux too. Then you have to mention that name, and you need to mention version also, most recent equal to true. If you provide like that, then it will fetch the latest version for you. Okay, this is how this works. Okay, next is debugging. Debugging in Terraform. Okay, like actually, this is one of the useful feature in Terraform. Okay, you can use TF underscore log. Okay, as an env variable. Okay, so you will, for example, if there is any issue, it will provide more information on that issue, so you can easily able to fix. So if you are new to Terraform, then you can use this command export small letter. Okay, tf hyphen log equal to true, not true, debug. If you provide like this, it will provide a more detailed logs for you. So since if you are new to Terraform, you can easily using this, you can able to fix without anyone dependencies. Okay, even in my initial days while I am learning Terraform, what I have done is I just use it this command, so I'll get detailed logs. So using that I got familiar. Now I can able to work without this tf log underscore debug. Actually, Terraform plays a major role in interviews. Okay, so provide more like spend more time on Terraform. Even now I am planning to switch. Okay, so most of the companies spending much time on Terraform only. Even like I am getting I'm getting shortlisted because of Terraform only. Since I am very good in Terraform, I can able to explain any concept. They are simply shortlisting me. They are not even checking remaining things. So Terraform plays a major role while coming to interview. Like how I got familiar is, if you are normally working for a company, it is difficult to remember all the concepts and the syntax. But the thing is, I am here working as a trainer, right? So every month I will do Terraform batches. So I know like each topics, right? So I'm just explaining like how I am explaining this to you people. So they're simply not asking more than 10 questions. Okay, they are they are like they itself will tell, if you are able to answer well, they tell you are good in Terraform, so we can move next, like that. If it is specifically infrastructure role, then they will shortlist you on the call itself. So these are all the advantages. Okay, so most of the companies spending more time on Terraform on interview. Even I am applying for DevOps role only. I am not applying for infrastructure engineering and all. Mostly they are spending time on Terraform and Jenkins. Okay, so Jenkins is will come under like a DevOps syllabus, right? I hope most of you learned Jenkins. Okay, so spend more time on Jenkins and Terraform, which will help you to get job easily. And if you know Ansible, it will be an added advantage for you. Okay, 30th one is Terraform format. Actually, why we need format is it will format configurations to ensure consistency. For example, if you are writing a code, but which is not in the Terraform standard while looking, okay. So if we execute Terraform FMT command, it will what it will do is it will format your code. So for ensure to ensure the consistency, okay. So you can use this command. Okay. Next one is validating Terraform configuration files. Okay. Now where we are, think up to this is enough. After that, we will have practical sessions. Okay. Next is 14th one is validating Terraform config files. If actually, since A is not working, it may not look well. Just wait. Let me update it. Yeah, now it will. What is the purpose of this? Actually, Terraform validate command checks the configuration syntax and logical errors. If there is any issues with your syntax or logical errors, okay, so it will let you know. If you execute Terraform, just an engine software which should be small. Terraform validate. VA validate. Okay. If you use this command, if there is any syntax issue or logical errors, it will let us know. Okay. This is enough while coming to theory, because last two class we have done theory only. So now we will focus on practical. Okay. Like up to 4, we will focus on practical only today. Okay. Okay, we will discuss what and all we have learned, how what and all best practices we have to follow while writing code. Okay. Again, tomorrow will be theory class. Next class will be practical class. Okay. After one theory, one practical, like that it will go. Okay. Now, now theory ends. Now we will start practical. Okay. I hope last class itself I told, right. You should have an AWS account. Is anyone having AWS account? Who has AWS account? If you share,
Yeah, Kishore.
like, you will get good hands-on experience. Okay, then can you share your screen so we can learn and we can implement all these things?
Sure, I will share the screen.
I'll guide. Okay, you no need to
Yeah,
worry. I'll just guide you. So understand and do. You will get good answer. And
yeah,
one
I
more
share
thing.
the screen.
Yeah. One more thing is hereafter. while we are having practical sessions, don't terminate this. Okay. Now who is sharing screen? Madhu, I think. Okay. So
Yeah.
just don't terminate this. You can stop this. Okay. So what we can do is in next hands-on we can just carry forward with this. So you will also have good continuity. Okay.
Okay.
Just give me a minute. I will share you the one link. Okay. Just give me a minute. So first we will first create one new server for Terraform. Just click EC2, or if you are having any existing servers also we can use. Okay, it will not take much memory. I think you don't have any instance, right? Just create one. Okay.
Yep.
Use Ubuntu. Okay, Ubuntu 22.04 version AM. Okay. And don't terminate this. Okay.
Okay. Which one? 24? 22, right?
22.04. Yeah. Okay.
Yeah.
Remaining and I'll go by default. No issues.
The network and remaining things default only, right?
Yeah, everything default. Just click launch instance.
Okay.
Others also please do it. Okay. Otherwise you will forget. Yeah. Now you have Visual Studio Code, right?
Yep.
Yeah, just connect this machine in Visual Studio Code. Do you know, or I need to guide?
No, I don't know that.
Okay, then I'll guide you. Just go to Visual Studio. Okay. Now in right side, uh, not in right side, in left side, you can see, yeah, in that after extension, yeah, below that, yeah, Remote Explorer, you can see, right? Just click that. Okay. Now here SSH, you can able to see SSH, right? No, in the top, yeah, in the same line you can see settings button, right? Just click that settings button. Now click that first file .ssh config. Yeah. Okay. Now line number 2 in host, give some name. Line number 2, I mean. Oh, no, not that one. Line number 2, that is line number 3, right?
Okay. Can
Just
I
give
remove
some name
alias
here.
or?
Yeah, you can remove that and give some name for your flexibility, like Terraform, test, like that. Okay. Now just go to your AWS account and copy your public IP. And just replace that with in line number 3 in orange color, you can see host name, right? Yeah, just replace that with this. Okay. In user, just remove that and type Ubuntu. For others, I will let you know, okay, how to install this extension. You have already installed it. Okay. So I will guide you like how you can install if you are new to Visual Studio. Okay. So don't worry. Then click enter. Now in next line type capital I, identify. Yeah, second one. Now space. You have that PEM file, right? That we have used. So just copy paste that path here. While creating
Uh,
instance, you choose one PEM file, right? Do you know that path?
which, no.
Then why we have chosen it? You can create new one, right?
Sorry,
If you
which
don't
one
know.
you want? This one?
No. Yeah, this server is there, right? We
Yep.
have used one PEM file, right? For this, just
Okay. That one. PEM file, I know, I
yeah,
know. 1 minute.
yeah, Then just go there. Yeah, keep here. Yeah, just copy the path of this. Paste. You have to mention your PEM file name also. Just copy paste from the nginx web server.pem is there, right? That is your name.
Yeah.
So just copy that name. You have to copy that name.
Yeah, I'm doing.
Click show. Yeah. Good. .pem also needed one. .pem. Okay. Now press Ctrl S.
Yes.
Okay. Now just you in the top like remote tunnel SSH you can able to see, right, in the left side. On that page you can see reload button, right? Just click that reload.
Yeah, I done.
Yeah. Okay. Now good. Now under SSH you can see test, right?
Yes.
Yeah. In the same line you can see one box with the plus symbol, right? You have to click that. Yeah. Click it. Now click Linux. Now click continue. This is the procedure. Okay. Others also please listen and do it. Permission denied. Is that key is correct? Just go to your AWS account. I check whether you have used the correct key. So just to scroll this on. Wait. Just I'll take control of your screen for
Sure.
some time. Just accept it.
Yeah, done.
Okay, it's correct only. Nginx web server key name. Okay, you are getting permission issue. Just give me a minute. We will fix this.
Okay.
Do you have do you have Git bash?
No.
Okay. Just wait a minute. Okay. Okay, then open your PowerShell. I will share two commands, okay? You execute because it will be fast for you. Okay. So since you are using Windows, this is the command. Okay. Just paste this command in a notepad. I will let you know what you have to do. Yeah, in key name is there, right? Your key name. Just remove that. Wait. Just remove that your hyphen key key.pm and use the path of your PEM file. Copy that from your notepad itself, like VS Code itself. Don't copy from here. Just copy from your VS Code itself. You have already done, right?
Is it fine?
Yeah, in second command also you have to do the same. I mean, like I have copy pasted the second command multiple times, I think. So one command is using
Okay.
enough. On last command, okay?
Yeah.
Yeah. Now execute this in your PowerShell one by one. Open just open your PowerShell and execute this.
Then
Okay, actually it is failing. Just copy paste that error in chat box. I'll check.
oh, yeah.
Okay, just okay. Just give me a minute. I'll just check why you are getting this permission issue. Okay. Now I will share one command. I just updated. Okay. So just copy paste this command directly.
Yeah.
It is processed, right? Now just go there.
Yes.
Just go to Visual Studio Code. Yeah. Now just click retry. Anyway, you close it. No issues. No issues. Just wait. Just wait. I'll do.
Yeah.
Actually, just close your Visual Studio Code and reopen it since you have updated permission. Close this also. Close this everything. Yeah. Now reopen this. Okay. Just wait. I'll open. Okay. Okay. Then what you can do is just go to that path. Okay. This is the path, right? Nginx. Where is that?
This one.
Yeah. Just wait. Just copy this. Where is your C?
C drive, right?
Yeah. Go to C. Mm, yeah. Just go to Visual Studio. No. Visual Studio Code. Just go to that app. Yeah. Wait. Let me go. Okay, users. You can see this path, right?
Yeah.
Dot SSH config. Go to dot SSH folder.
Sure. One. Yeah.
Yeah. Just paste it here. Let me paste. Okay. Now copy this path. Okay. Go to Visual Studio Code. Actually, I am going. Just wait. Okay. This is how in single chart you can paste. Okay, identify. Just let me check one more time. User host name host. Okay. Okay, everything is good to go. It is connected successfully. It's due to permission issue. Okay, that we have fixed it now. Okay, now let me maximize this. Okay, this is our server. Okay, now let me open this server in. Okay, so this is our server. Okay, I just shared you one link in a not like in chat box. Right, just go to your chat box. Okay, now what we are going to do is we are going to install Terraform. Okay, so since yeah, first one, you can save this link. Okay, using this only we are going to install Terraform. Okay, Madhu,
Yeah,
do you do or let me do since I have access to your screen, which is flexible for you.
I'm not much in the Linux related things. You can
Okay,
go
then
on.
what you can do is just listen, okay, and let me know any doubts.
Sure,
I'll do first.
sure.
If screen is show, just I excel something, you just to do that. Okay, just scroll down now. Scroll down, scroll down, scroll down. Yeah, stop it, stop it. Okay, first one is what we are going to do. We are just going to upgrade our server. Okay, we are just going to update our server. And I am going to install that in my server. Okay, so in Visual Studio Code, if you want to paste, then you have to use Control Shift V. Okay, this is the command to paste. Okay. I will let you know like how to install extension also in the meantime. Okay, here you can see extensions, right? The thing is this remote explorer we have used it, right? Actually, this is one of the extension. Since we already downloaded it, we just configured it. Okay, so if you are newly installing Visual Studio Code, it will not be there. Then how you can download it? Just click extensions. In extensions, you have to download two things. One is Remote Explorer. Remote Explorer. Remote SSS is there, right? This you have to install. Just see this you have to install. Okay, Remote SSH and Remote Explorer. This is Remote Explorer. Okay, and you have to install Remote SSH also. So this two is must. Okay, this is Remote SSH. Okay, SSH and the Remote Explorer. Both you need. Okay, just remember this. You need to do this. Otherwise, you can't do. Okay, so if you do that, it will show this icon. Okay, so this is how you have to install. Let's carry. Now first we are updating it. Okay, it will take some time. We will wait. Okay. Now, next step is where is your browser? This is the browser, right? Yeah. Now, what we are going to do is we are going to install this Snap Package Manager. Okay, this is one of the Linux contribution. We can install this. Okay, so using this we can install our Terraform. Terraform is open source. Okay, we don't need to pay for this. Okay. Control Shift V. I'm just telling one more time. So since people are new. It is already there by default, it will be there. Okay, so if it is not there, then it will install. That's why we are using executing this command. Next is now we are going to install Terraform. Okay. We will wait, depends on internet speed. It will take time. Okay. Actually, it seems your internet connection is slow, so it's taking time. Okay, no issues. We will wait. Okay. Everyone do this, okay, without fail. Otherwise, it is difficult to get hands-on with the Terraform. Okay, everyone must do. Okay, now we have installed Terraform. Okay, we can verify this installation using Terraform version command. Why I am not using this default copy is it is copying this dollar symbol also. So we should not copy that. It will not work. That's why I am copying this. Now Terraform is installed successfully. Okay, so now actually I have the code. I will share that so we can execute and we will check. Okay, so just give me a minute and we will learn all the concepts. This is the repo URL I will share with everyone so you can use this. Okay, so first what we have to do is first we will clone the code. Just wait. Okay, yeah, this is the code. Okay, so just we will clone this code now. If you are already completed DevOps class, then you know like how to clone. If not, learn how to clone. Okay, because this is Terraform class. So I can't teach GitHub here. So I just copied this from my Android. This is public repo. Okay, so you can just like that you can clone. Here you can see Terraform practice, right? So this is the folder. Here, Terraform practice 2 is different. Okay, that is our next hands-on. So I'll just move that out. So to avoid confusions. So okay, so we have this one. Okay, so this is the thing we are going to discuss now. Okay, here before that, actually now this is AWS server, right? And if I want to create an if I want to create any resources using Terraform, then it should have that permission, right? So what you have to do is you have to create access and secret key, and you have to use that here, okay, for authentication from your Terraform code to your AWS as of services. Okay, we know, right? We will use provider.tf if since we are going with AWS. So AWS is our cloud provider. So what Terraform provider will do, it will act as an API. Okay, it will act as a plugin. Okay, and it will communicate with the API of services. So AWS API they will have. So using that they will like Terraform. What it will do is it will find AWS. It will install AWS letter plugins, everything. Whatever we need for AWS infrastructure, it will download everything. Okay, so you can able to communicate uh, from Terraform to AWS. But for authentication, we need some authentication, right? AWS should allow, right, Terraform to do that. So for that, we can configure this with access and secret keys with the help of IAM in AWS. Okay. Now what we are going to do is we are going to create a access key and secret key in our IAM, and we are going to add that here. Okay. I'll just go to AWS account. Go to IAM. Since we are practicing, we can use our root user itself and we can create. Here you can see create access key, right? So here we are going to create it. And I am going to use this for a command line. So I am mentioning it as CLI. Okay. And I am just confirming this. Actually, it will be only visible one time, okay? So what we have to do is we have to store this in somewhere. Otherwise, you can't access it. Just we will download this. See, I have just downloaded this CSV, okay? So after this class, keep it safe. Okay. So now we will just copy paste this in Notepad. This is access key, and this is secret key. Okay, this is very important. Okay, if you are working in a company, you should not expose this. If you expose, hackers can do anything with your account. Okay, so you should not expose this on real time. Okay, it should be very safe. Now we have to install AWS CLI here. Okay, I think AWS CLI will not be here. If I use AWS, oh, A is not working. Just type AWS. Yeah. See, it is showing right. It is not there. So we have to install it. So we will install it with the snap. Control Shift C and Control Shift V we have to use. Classic. Spelling A again. A is not working. Just you type it as a classic.
1 minute.
Enter. Yeah, it is installing. Since we are setting up everything, don't terminate this, okay? Because each and every
Sure.
class is difficult to set up. You know, right? You can see, right? It is taking nearly half an hour to set up all these things.
Correct.
Like if you are taking leave, also let me know. Okay, message me.
Sure, definitely.
Okay.
Terraform, it should be the only Ubuntu OS only we need to install, or any other flavors it's about.
We can install it on any flavor. Okay, since Ubuntu
Okay.
is widely used, one we are going with Ubuntu. That's it.
Okay.
There is no specific reason. Okay. Since it is widely used, we are going with this.
Yeah, it's installed.
Yeah, okay. Now we will configure. Okay. AWS configure is the command. Just type AWS configure. AWS space configure. Yeah, just wait. I'll do access key. Secret key. They're going by default. Okay. Now we have done setting up our IAM access and secret keys. So for choosing AWS, provider will take care, and for authentication, our AWS configure will take care of our access and secret key. Okay, so now we know like how it is choosing AWS and how it is authenticating. Okay, so now we will discuss about the code. So whatever we have discussed till now theoretically, now we will discuss that in practical. Okay, so Terraform practice. Here, like I said, right, we have to write the providers.tf file, and we have to provide the required version. Like that, I said no, and we have to provide region. Okay, so in provider.tf, I just returned Terraform. Actually, this is the syntax to write provider.tf. Okay, in required providers, already we have seen everything in our theory class, right? So in required providers under AWS, I am mentioning source as ASICRAM. Okay, so I am downloading that API of services from ASICRAM. Okay, so and while coming to version, I am just using 5.0 as a version. And I'm specifying required version also 1.3 to 1.3.0, like that I am specifying. As well as while coming to provide, like this is for required providers, and we have to specify the region where I am going to deploy this. And I am going to deploy my infrastructure on AP South 1. Okay, this is Mumbai region. Okay, I'm going to deploy my application, my infrastructure on Mumbai region. Okay, since it is very near to us, so I have chosen Mumbai region. Okay, this is providers. The purpose of providers is just to choose cloud provider and authenticate it with the required version, as well as to choose the region. Okay, now what we are going to do is we are going to create EC2 and S3. EC2 instance and S3 bucket we are going to do. Okay, so wait, you can delete this file actually by mistake. I sent this. Okay. So EC2.tf. We already know everything here. As I said, the best practice is using variables, right? Here we can see while creating a resources definition, I just use AWS instance, which is resources type. And while coming to local resources, I created as a web server. Here we can see AMI. I have not injected AMI directly here, as well as instance underscore types also, instance type also. I am not injected here directly. Here I just mentioned my tag. My tag is my EC2 instance. Okay. So what I have done here, I've used variables file. From variables, I'm fetching my AMI and instance type. If I go to my variables.tf, here I have declared all the variables. Here you can see variable instance type. By default, I have given T2 micro. So it will use T2 micro. Variable AMI ID also I have given. This is the AMI ID it must use. Like that I have given. And bucket name while creating S3, we will discuss okay while we are coming to S3. Okay. So while coming to EC2 instance, I have created two variables and I am calling the two variables in my manifest file. Okay, in my resources definition. Okay. Now S3.tf. Here, I just created a resources definition for S3 bucket to create S3 bucket. Okay, so this is the resources type AWS S3 bucket, and the local resources I have given as my bucket. Here you can see bucket name also. I haven't mentioned directly. I have used variables.tf and I have given. So this is my bucket name. Okay, we will just change this name because bucket name is unique. Okay, I don't know whether I have created this bucket previously. So just I'll add some more content also here. So this bucket will not be there. Okay, and I am just saving this. Okay, so this is my product.tf. This is my s3.tf. This is my variables.tf. Output. Like we have learned about computer values. Did you remember? Like just like uh, I am like we are seeing your screen, right? Uh, wait.
Google form, right? You're talking.
Yeah, Google. I have written right.
Yeah,
Like
yeah,
can
one
you
minute.
open it? Yeah, correct. Just give me a minute. Okay, like scroll down here, you can see we saw drawbacks of computed values, right? So I have explained, right? While you are in planning phase, you will not get entire details like that. And all we have challenges with current state, everything we have discussed, right? So in planning phase, you will not know the IP address or any other information. Okay, that for that only I ask you to open. Okay, just go to Visual Studio Code. So for that only, I have written output code. Okay, for that only, I have written output.tf. To overcome also we have discussed around that time. Just wait. Yeah, output.tf. The reason for writing this is it will not show your public IP or instance ID once it's created. But we need to know, right? So for that, uh, to avoid misunderstood or misconfigurations, I have written output file. So after an EC2 instance creation, I need my ID of my EC2 machine and bucket name. Okay, both I need. So I have given this as an output. Okay, so now we are going to execute this. Where is terminal? Yeah, Terraform. Okay, now here first step is Terraform init. What it will do? It will initialize your current working directory as well as it will set up backend system for you to execute upcoming commands. This and all we have already discussed. Okay, so type Terraform because A will be there in Terraform. So I can type Terraform space init space init. Click enter. Now what it will do? It will install our required provider and it will choose the uh, like a cloud provider as well as it will specify the region as well as it will authenticate as well as it will create backend system to execute upcoming commands. Okay, now it was success. Terraform init was success. So we learned it just now, right? Terraform format and Terraform validate. That are all useful commands to structure your configurations. Now type Terraform space FMT. Terraform space FMT. Click enter. It will just format your code. Okay, now it is formatted. Now we can validate for logical errors or syntax, right? Using Terraform validate. So execute Terraform space validate. These are all best practice. Before doing plan, we have to check these are all things. Okay.
One time is enough, or whenever we are running the
Whenever you are
Terraform?
changing manifest file, you have to execute this.
Okay.
So it is clearly showing that success, the configuration is valid. Okay. Now we can do plan. Okay. So type Terraform space plan. I will show you that computed values. Okay. No. Since we haven't discussed about state files and all we will discuss one by one. Okay. So you can see noun after a play, noun after a play. These are all the drawbacks. Even while you are planning, you will not know what will happen on next. Even see, EC2 instance ID, known after a play. Everything will be known after a play only. Scroll up a little bit. That is the drawback. Okay, we can see as scroll up a little bit. See, known after a play, key name, everything will be known after a play. Only it is showing AMI that we have given. Everything, CPU core count, disable API termination, everything, host ID, like ID, instance ID, shutdown behavior, instance life cycle, everything will be on IPv4 address, IPv6 address, key name, monitoring, everything will be known after a play only. That only I have discussed as a drawback. Okay, that only we had in our syllabus. Okay, subnet ID, everything was known after a play only. Only whatever information that we have given in manifest file, it will show that. Okay, so scroll down and we will check how infrastructure is creating. Now type Terraform space apply. Now it will ask for confirmation. We have to type it as S. You just wait. Now you have to type yes. Before typing yes, you can check everything what and all it will do. Okay, like it will create EC2 and S3 bucket. Okay, so since you have typed yes and click enter, it is started creating our resources. Okay, once it is started create, yeah, it is created. You can see output. Since I have written output file, it is clearly showing my instance ID and my bucket name. If not, it will not show. Like this, you can see public IP by writing output file. You can see public IP, private IP. Everything is possible here. Okay, now I have written to check only my instance ID. My instance ID is ending with 8B, right? So, for example, you are already having 100 missions. Now it is created new mission, but you don't know means using this instance ID you can filter, right? That's why I have given instance ID. Okay, so just go to your AWS account. It will create one EC2 machine and one S3 bucket for you. Just reload this page. Yeah, you can see second one, right? This is the machine, my EC2 instance, the tag we have given. It has been created by Terraform. Okay, go to S3 just later, like I'll take screen. Okay, here you can see this is the machine that we have created. It itself will you configure everything and it will create for you. Here you can see instance running. It was perfect. Okay, it is initializing. Once initialization is done, you can able to access even this server. Okay, now we are going. We will check S3. Okay, we have created one bucket. We will check whether that bucket has been created. Here you can see my unique S3 bucket. It has been created just now. If I open this, no object. We haven't given any object. We just created the bucket, right? This is our bucket. Okay, this is how you have to create. Okay, is there any doubt? Now you can able to understand, right, what and all we have discussed around how to implement those things. For example, if I want to create a 10 EC2 instance, then what I can do here, I can just use count equal to 10. Then it will create 10 EC2 machines for us. Okay. So this is how you have to handle the things that we have learned. Okay. Is there any doubt? Are you able to understand how computed values works, how Terraform plan works, Terraform apply works? Okay. Now we are going to test drive this. Okay. Because it will unnecessarily charge us, right? Why we have better type Terraform destroy. This is the command, it will destroy everything. Okay, you don't need to destroy anything manually. Terraform destroy.
With
It will ask
existing whatever we have run, that one will delete or overall servers will delete
no, it will
in
not
real
delete
scenario.
overall. What and all services we have created using Terraform, it will destroy.
Okay, in real type scenario, we have using multiple things. At that time, if you run this command, means it will affect all the ones, right?
I think you didn't understand what I said. The thing is, what and all resources we have created that it will destroy. For example, if you want to destroy only one service or two service, then you should not use destroy command. Here we are going to destroy
Okay.
what we have created. One EC2 and one S3 we have created, right? So we are going to destroy that. For example, in real time, okay. In your case,
Yeah,
you said right 4 instances you have created, but you want to terminate only one. Okay. So in that case, what you can do is, while creating 4 instances, you will use count, right, as 4. So you can reduce
yeah,
that count as 3, okay, and you can apply. So what it will do, it will delete one instance. Otherwise, what you can do is, you can destroy each resources manually, like using Terraform destroy. We haven't mentioned any resources now, right? So if
correct.
you want to destroy only specifically S3 bucket or EC2 instance, then you can mention resources type and local resources and ID. I will show that and all we
Okay,
will learn in upcoming classes. Okay, how to destroy a specific resource. Yeah, this instance ID is there, right? So while
yeah,
using Terraform destroy command, you have to provide this also as an argument.
okay, got it.
Then it will destroy only this instance. Once it's destroyed, you can remove that code in your Terraform configuration and you can save this. So it will not create any problem. Why I am asking you to remove that code in Terraform configuration file is otherwise, again, while you are doing apply, it will install. Okay. Again, it will create that instance. So if you don't need
Yeah,
something, first you have to destroy with command. After that, you have to remove that code. Understood?
okay, yeah,
Now go there, you can't see the newly created resources. We can see only our current server that we are running, right? That we haven't created with Terraform, no. So it see no buckets. Even that new server has been created, right? It will also be destroyed. See, terminated. This is how it works. Any doubts? Are you able to understand? We are going very slowly, and I have explained everything in detail. Any doubts? Are you clear? Madhu only, right? Are you clear, Madhu? Like
yeah,
you asked
yeah,
me.
yeah.
Okay. Okay, if there is no doubt, we can end this class. Okay, for past 1 hour 40 minutes we had call. Okay, this is enough. Tomorrow we will discuss some more theory concept. Next Saturday again we will have hands-on with newly learned topics. Okay, so
Okay,
Madhu, what you can do is just stop this instance. Just select that one. Just yeah, go and stop this. Don't terminate this. Okay, it is very difficult to set up it again for
yeah,
me.
yeah.
If you want to learn or
Okay.
do anything, you can do with new servers.
New
Don't touch
instance.
this.
Yeah,
Okay.
yeah.
If you want to
Sure.
practice, then you can do, but don't destroy or add anything else because
But
you saw right. It takes nearly 30 minutes for us to set up everything.
yeah, yeah. I will make. I mean, for practice, I will take a new instance for this.
Yeah. Okay. Like it is free tier only, right? 750 hours you can use. Okay. You
Yeah,
can rent 2 machines. It will not charge you. Okay.
yeah,
If you are running third machine, then start and stop. It will not charge you. Okay.
sure.
So learn from dynamic blocks. Okay, so from dynamic blocks onwards we will learn. Today is theory part. Okay, yesterday we had hands on. I hope you guys have tried it. Is there any doubt? Yeah, is anyone provide, and do you have any doubt? If there is no doubt, then we can move further. Okay, like today we will have theory class. Next class will be an hands-on. Okay, so what and all we are covering today. Next class will be an hands-on. Okay, so practice it. Okay, so just watching or listening will not helpful for you. Okay, we have to do by yourself. Then only you will get good hands-on. Okay, so let's start. Next topic is dynamic blocks. Dynamic blocks. Okay, while coming to dynamic blocks, okay, the purpose of dynamic blocks is it will allow. Okay, what it will do is it will allow you to create resources configuration dynamically. Okay, as name indicates. Okay, it will allow you to create resources configurations dynamically, enabling flexibility in defining repeater or conditional elements within a resource. Why we use dynamic blocks? When number of subblocks varies, then we will use dynamic blocks. Otherwise, when subblocks are determined programmatically based on variables. Okay, so we will use like this. So or like if you want example, then we will use ingress rules and all, right? So inbound and outbound rules. So for that we can use dynamic blocks. Okay, mostly we will we will not use dynamic blocks. We will handle with variables itself. Okay, like the major purpose of dynamic blocks is it will allow you to create resources configurations dynamically. A is not working, so only it's like this. Let me update it. Okay, it will allow you to create resources configurations dynamically. Okay, this is the purpose of resources blocks. Okay, tainting resources. Yeah, actually we will use tainting resources. Okay, tainting, tainting. A will come. Okay, TA tainting resources. What is the purpose of tainting resources? Actually, like Terraform uses tainting to mark a resource for forced recreation during the next apply operation. Okay, it's useful when you want to replace or recreate a resources without changing its configuration. Okay, this is a purpose of tainting resources. Okay, it will mark like a tainting. We will use to mark, yeah, resource for forced recreation during next apply, during the next apply. Next apply means next Terraform apply command execution. Okay, like example is how you can taint your node is using command only. Okay, to taint a node we will use Terraform taint. A will come. Okay, my keyboard is not like A is not working in my keyboard, so only you are getting like this. Okay, so like for example, if I want to taint EC2 instance, then AWS underscore instance is the like resources type, and you have to mention the local resources. Okay, this is to taint. Okay, if you want to untaint, then you have to use Terraform untaint. This is like this taint and untaint we will handle with uh, command only. Okay, you no need to write any code. Instance dot example. Okay, this is to taint, this is to untaint. Okay, okay. Why we use taint? You may have questions, right? Why we use tainting? You may have this question, right? The purpose is to repair a resource that may have drifted from its desired state, from from its desired state. Okay, otherwise to trigger recreation of a resource due to external changes. Okay, this is why we use times. Okay, splat expressions. Okay, you need to be multiple attributes from resources or variables. Okay, it will simply referencing multiple. It will simplify. Okay, it will simplify referencing multiple attributes from resources or variables that written list. Okay, they are integrated by list. Inside list we will use star. That is a syntax. Okay, let me type that syntax. This is the syntax. Okay, like for example, I want to create an EC2 instance. Okay, then we will mention count, right? Then what we will do, resource, it should be small letters. Okay, resource. Okay, it's okay. Resource AWS instance example. Okay, now here I'm going to give count as 2, so it will create two EC2 missions for me, and I'm declaring AMI. Okay, AMI, it should be AMI equal to something. Okay, and the instance type we have to give, right? So now I am giving instance type I am giving it as T2 micro. Okay, now I am closing this. Now you can use this splat expression on output. Did you remember yesterday also we had one file called output.tf? Using that only we have retrieved our instance ID and our bucket name, right? So if it is one, we can directly provide that count dot index like that. But if it is 2 or 10 or 15, it is difficult to provide those values, right? We can easily iterate that with the help of output. How you can do is output instance IDs. Instance IDs value AWS instance dot example. Okay, here you can mention that instead of count index or something else, instead of count index or any other name, you can just press, you can use star. So it will itself take first as 0, second as 1, like that. Okay, it itself will iterate. Okay, this is the purpose of like a splat expressions. The major reason for using it, it will simplify referencing multiple attributes from resources or variables. Okay, that is the main reason for using it. Using it here, you can see this, right? This sentence, which retrieves the idea of all instance in a single operation. Okay, but you can ask, if I didn't use splat, then how I can able to write means, here we have to mention 0. Again you have to copy this, and again you have to use comma, and again you have to copy this, and you have to use 1. Okay, if you are mentioning 10 here, then you have to write this kind of list up to 10. Okay, it is waste of time, right? So you can use flat expressions to iterate those, so you will get instance idea of all the 10 instance. If you are creating 10 instances using star, you can easily get. Okay, so splat expression will be very useful while writing the code. Okay, if you are creating more than one instance, then instead of mentioning 0, 1, 2, 3 like that, we will mention star. Okay, so it will print all the output IDs, like input, like instance IDs that you need. Okay, now next one is Terraform graph. Terraform graph. Okay, while coming to Terraform graph, like a Terraform graph command, visualize the dependency graph of your Terraform configurations. Okay, like what it will do, it will visualize the dependency graph of your Terraform configuration. Dependency define the order in which resources are created or updated. You can use, you have first for that, what you have to do is, you have to install graph VIZ. Okay, you have to install this if you want to use Terraform graph VIZ. You have to install this. Okay, once you install this, you can use Terraform graph command to visualize your configuration files. Okay, so you can visualize your Terraform configuration files. Okay, so it will display configurations in graph format. Okay, next one is saving Terraform plan to file. Yesterday we saw, right, once we have executed Terraform plan, it has shown what and all changes may happen if I execute that configuration, right? Like in last class, while we are doing manually, we saw like we have created one EC2 machine and one S3, right? So in plan, it's clearly showed, right? It configurations of S3 and configurations of EC2 instance. So if you want to save that plan, we have a command to do it. Okay, that only we are going to learn. Learn. Okay, you can use Terraform. Everything will be in small letters only. Okay, Terraform plan hyphen out equal to tf plan. Okay, this is the command. Okay, to save the plan. How you can apply the saved plan is to apply the saved plan. We will use Terraform apply tf plan to apply this plan. Okay, so it will store the plan in this name, and we if you need to apply that plan, then you can use that name to call it. Okay, it will the major benefits is it will ensure the consistency between plan and apply. It will be useful for team collaboration and CI/CD pipelines. Okay, next one is Terraform output. Yesterday itself we saw this even in a practical class. Even we discussed this before few minutes back also. Can someone tell what will be the purpose of Terraform output? Because while coming to theory, like I am explaining, I don't know whether you guys are able like listening or I don't know what you guys doing. What is the purpose of Terraform plan? Can someone tell?
So with today's class, I assume like it's for this uh for the team you were saying before some time.
What?
So yesterday's class I missed. So with today's class only,
Okay.
yeah. So just before some time you said like Terraform plan and applies for some CI/CD continuous plans and deployments and all within team like that.
No, I am asking about what is the purpose of Terraform output.
Terraform output. Okay.
Terraform output is once we apply the plan, none of the IDs will not comes to us until unless it is applied. Once we configure the Terraform output, the plan is completed and whatever the results which we need, like instance IDs, IP addresses, DNSs, it will
Yeah,
show
correct.
you.
Yeah,
If
correct.
we didn't output mention the output means we didn't find those details once we plan is executed.
Yeah, exactly correct. The thing is, with the help of Terraform output, if you want to view your created instance details, if you want to get your created instance detail, for example, if you are creating EC2 machine, you need instance ID of it or public IP of it. You are creating S3 bucket. If you need bucket name of it, okay, as an output, then you can use Terraform output. Exactly what he explained. That is the purpose. Good. Okay, like you can achieve this by writing the code. Like yesterday itself, we have done while we are doing practical itself. I don't know like how many of you listened it. Okay, so just joining here it will not help. Okay, so you have to listen. Yesterday we saw yesterday I showed you while doing practical sessions. I think Madhu, you remember, right? Like I showed that instance ID as well as bucket name. I hope you
Yeah,
only
Kishore.
shared it yesterday.
Yeah.
Okay, so just remember, otherwise watch last class video, it will be better. Okay, for example, I have created one EC2 machine. After after once it's created, I need to get public IP of it as a output in my terminal means. Then I can write a code. Okay, output.tf code I can write. How I can write is output. This is how you need to write. Okay, output instance public IP. Okay, since I need public IP of my instance, then I need to in value. You need to follow the syntax. Okay, the syntax is resources type resources type is here. We are going to view public IP of EC2 machine, right? Then we have to mention AWS underscore instance. Okay, dot local resources. That is our next name. I am giving it as example. Then I need public IP of it, right? Then you can type public underscore IP. Okay, so and if you close this, so after instance creation, it will show the public IP in your terminal itself, in your server itself. You no need to go into AWS account and you no need to check that. You will get here itself. Okay, that is the thing here. Okay, if you if you want to fetch with the help of CLI, this is in code format. If you want to fetch with the help of CLI, then that's a command called Terraform output instance underscore public underscore IP. Okay, if you need this in a JSON format, then you can use like a Terraform output hyphen JSON. Okay, next topic is Terraform settings. Terraform settings. Like what is the purpose of Terraform settings is like a Terraform block specifies meta configuration settings, right? For your Terraform configuration. Like the same thing here. The reason for using Terraform settings is if you want to configure your state file, like if you want to store your state file on a S3 bucket, then you can do it. Okay, like already we have written code for Terraform version, right? Just wait. Otherwise, I'll open our GitHub and I'll show you. Just give me a minute. Are you able to view my GitHub? Here we have written provider.tf, right, yesterday. So here, like what we have done, we just created, like we just specified our version and the required version and in which region we are going to deploy. Am I right? Additionally, you can use S3 configuration to store your state file. Okay, for team collaboration. You can get it from S3 bucket. Okay, that is the purpose of Terraform settings. Okay, like the major reason for using this is for storing state file securely. Okay, next one is Terraform, like dealing with large infrastructure. Large infrastructure. Okay, like how you can manage large infrastructure with Terraform. That is the one we are going to discuss. I think we are going saving computer settings, dealing with large infrastructure. We are here now. We have zip map and provisions. Okay. Okay. Like managing large scale infrastructure in Terraform requires strategies for organization. Okay. Performance and maintainability. The best practice is you can use modules. Okay, you can use modules. You can use modules for large infrastructure. Okay, why we need modules? The thing is, the main reason for using modules is it will break configurations into reusable and logical modules. Okay, it will break configs into reusable and logical modules. The modules. Okay, so like what and all things, best practices that you need to follow while working with a large infrastructure is actually in my keyboard. Now also A is not working properly. That's why I'm doing like this. Okay. Second one is first one is we can use modules. Okay, we can break configurations into. Okay, we can break configurations into reusable and logical modules. Okay, we will discuss about modules in detail. Okay, second one is remote state. Okay, these are all best practices you need to do if you are working with a large infrastructure. Second one is remote state. Before that, we discussed it, right, to store our state file on the S3 bucket. Okay, because state file is very important one. Because in state file one, using state file only, Terraform will compare current state versus desired state. Like the thing is, for example, in your code, you are writing code to create two instances. Okay, and it is created one instance. While you are creating another resources in Terraform, it will compare our previous code with infrastructure. If it is correct, then no issues. Otherwise, it will throw you with the error. It will show that our current state is mismatched with the desired state, like that. Okay, so state file is very important. As well as in state file, it will store our instance details, S3 details, what and all resources that we are creating using Terraform. It will store all the sensitive data in the state file. So state file is very important one. Okay, okay. So the best practice is we have to store our state file in remote backend like S3 to enable collaboration. Okay, state store state in a remote backend. Okay, okay, to enable collaboration. And like example is S3. Okay, to enable collaboration. Next best practice is you have to use Workspace. Workspace we have already discussed yesterday. The purpose of workspaces, for example, we have stage environment, dev environment, production environment means you can use same code for different environment. Okay, to store and maintain it properly. Okay, you can use workspace for that. Okay, you can use workspace to manage environments. Manage environments. Yes, like a stage, dev, prod, and all. Okay, within a same code. Okay. Fourth one is parallelism. 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 This is to increase parallelism during apply to improve performance. Okay. So this and all the best practice we have to do while dealing with large infrastructure. Okay, just to increase like this is just to increase parallelism during apply to improve performance. Okay, like you can achieve this with the help of Terraform apply hyphen parallelism equal to 10, like that you can use. Okay, next one is zip map. Zip map also important one. Zip map function. Okay, the purpose of zip map is like it creates a map by combining two lists. Okay, one for keys, one for keys, and another for second one is for value. It's a key value pair. It's like a dictionary in programming languages. Okay, now how you the syntax for zip map is zip map key comma value. Key comma value. Like example is, for example, if I want to create my infrastructure on two regions with two AMIs with means how I can combine with the help of list and the zip map functionality you can do it. Okay, for example, I'll write an example and I'll explain. Okay, now what I'm going to do is I want to create my infrastructure on two regions with the same code. Okay, and I need to use for AP South one, I need to use one AMI ID. For US East one, I have to use one AMI ID to create EC2 instance. Then now I can do that. With the help of zip map, we can achieve it easily. Okay, first I'm just writing a variable. Okay, variable. In variable, I am just declaring first region default. I am in default. I am providing list. Okay, in that list, I'll mention two regions. One is AP South one. AP South one. Second one is US East one. Okay. Now I need to create two AMIs, right? So again, I am going to create one more variable. Okay. Here I am mentioning AMIs. Here again in default, I will give two AMIs in a list. Okay. Now I have two regions, two AMIs, but how you will map this? Because my AP South one should use this only. My US East one should use this only. Okay, you should not mismatch at any cost. Then what you can do is you can write one output AMI underscore map. Okay, now I am going to map here now with value equal to zip map. So now I am going to use that syntax key value, right? Where dot region comma where dot AMS. So what it will do is this like since I am combining key as a value, this will act as a key and this will act as a value. This will act as a key and this will act as a value. So while you are creating regions and working with the different AMIs, it will work as expected. Then how you will get output is, okay, let me type output also. You will have output like this. US like AP South one is equal to this AMI. Okay. And for US East one also, it will create like US East one. It will use this. Like this, it will create the mapping between two variables. Okay, this is how zip map works. Okay, it will dynamically map regions to AMIs as well as it will simplify input configuration for complex resource setups. Okay, is there any doubt till now? Like we are here in our syllabus. Okay, up to this we have covered. Now we are here. Just I'll give 10 minutes time. Just revise. Don't leave the class. Okay, what and all we have discussed. Okay, just revise so we can start Terraform provisioners. Okay, now time is 2:56. Okay, 3:06 we will start Terraform provisioners. Okay, just revise. Okay, I hope everyone have this Terraform board link, right? If not, I'll share this in chat box. Just revise and let me know if you have any doubts so we can proceed further.
Showing issue.
What?
It's showing. It's showing.
Okay.
It's recorded already. Yeah. Recording.
Okay. Then. Actually, it is not showing for me, so I am confirming.
Share the screenshot as well in chat. I have highlighted.
Okay. Okay, then we can carry. Okay. You can able to view my screen, right?
Yes. Yes.
Yeah. Okay. Then we can carry. Okay. Our next topic is Terraform provisioners, which is very important. Okay. In Terraform provisioners, we will discuss about all these things. Okay. So let's start. Actually, what is Terraform provisioners? Actually, provisioners in Terraform are used to execute scripts or commands on resources after they created or before they destroyed. Okay, they are typically a last resort when specific resources configurations cannot be managed by Terraform alone. Okay, the major purpose is for bootstrapping resources. Okay, the major purpose is bootstrapping resources. Okay, example, what I can say, like installing software. Okay, installing installing software on a server. Next, purpose is you can execute configuration management tools. Okay, you can execute configuration management tool like Ansible. Example, Ansible. Okay. Next is you can running custom commands during resources creation or distraction. For example, okay, I am creating an EC2 machine, okay, manually. Okay, once while it is starting itself, it should install Nginx for me. Then what we will do? Can someone tell manually? Okay, I am going to create a EC2 instance. Okay, once it is started running, by default it should have Nginx. Then what I need to do? Manually, I am asking. Okay. Can someone tell what we can do? How you will execute commands? If it is wrong, also no issues. Just let me know. Guys, which is very easy, right?
Teacher, can you repeat the question?
I want to install Nginx. Okay. I want to create a EC2 instance. Once it is started running, by default it should have Nginx. Okay. While I am opening it. Okay. So while you are configuring EC2 machine, what you will do to install Nginx?
Uh, Default OS will be there, right? I mean, like a cloud trail
Yeah,
or
OS
something
will
we
be
can
there.
use it.
Wait. OS will be there. Then how you will
Okay.
install custom software, or if you want to execute script, then how you will do in EC2 machine?
User data.
What?
While we are building the machines,
Mm,
user data option is there where we
okay.
can run the script there. Once we powered on the server, it automatically install the configuration thing there.
Okay. For example, if I use any commands, do it will install that?
Yep. I think service restarts are those commands or
Yeah, like that one.
yeah. Yes.
Okay. Who is like answering?
Madhu.
Yeah. Okay, it's correct. Okay. The thing is, you have to use user data. Okay,
Correct.
you can use a data section, right? There only if
Yeah.
you want to execute any script, shell script, or if you want to execute any commands. Okay, for example, if I want to install Nginx, then what I can do, I can use sudo apt install Nginx, right? So it will install Nginx for me. So I can use that command in my user data section. the same only. So here, since we are doing in code, we can use Terraform provisioners to do it. Okay, instead of user data, while we are doing manually, we will use user data, right? So if you are doing in Terraform code, then we will use Terraform provisioners. Okay. So there are a number of purposes are there for Terraform provisioners. We are going to discuss one by one. Okay, are you able to understand now? Let's start. Okay, understanding provisioners. Understanding Terraform provisioners. Understanding Terraform provisioners. Okay, provisioners interact with your resources by connecting to them and executing commands. They are defined within a resources block, and they have two primary execution modes. Okay, there are two primary execution modes are here. One is creation time provisioners, another one is destroy time provisioners. Okay, creation time provisioners, destroy time provisioners. Destroy time provisioners. What is the purpose of creation time provisioners? It will run after the resources is created. Destroyed. Okay, so while coming to key points here is like provisioners rely on external communication protocols like SSH. Okay, even if you want to connect with the server, you will need SSH, right? So SSH port is 22. Okay, using SSH only we can able to connect our server, our terminal, right? So as well as another thing is they may cause issues if the resources creation fails. Okay, it will lead to potential resources drift. Okay, there are two types of provisioners are there. One is creation time and destroy time. These are all execution modes. Okay, you have to use creation time provisioners. Okay, after resources is created. Destroy time is before resources is destroyed. You need to use this provisioners. Okay. Now types of provisioners. There are two types of provisioners. These are all modes. Okay, there are two types of provisioners are there. While coming to types of provisioners, we have local executable provisioners and remote executable provisioners. Now we have discussed, right? I want to create a own machine. Once it is started, itself by default, I need to have some softwares like Nginx or Apache. Like that means, what we will do, we will use user data block, and we will add commands, and we will do it, right? So if you want to do the same thing with Terraform, then we have to use remote executable provisioners. Here, instead of user data, inside inline commands we have to provide. Okay, that is a difference. Okay, let me first we will discuss both in detail. First is local executable provisioners. Okay, it will execute commands. It will execute commands. It will execute commands locally on the machine where Terraform is running, where TF is running. Okay, while coming to remote executable, remote exe, xec executes commands remotely on the target resource with the help of over SSH or SSH only. Okay, with the help of SSH. Okay, that's why I said in our example we are going to use remote executable because that is a new server. Okay, while it is creating, we are going to install those servers, so it will connect with the help of SSH only. Local executors means, for example, you are going to create an EC2 machine and you want to store that IP address in text file in the machine where you are running Terraform. Then you can go with local executables. Okay, so this is the difference between local and remote executables. Okay, implementing remote executable provisions. Okay, so how you can implement this? Okay, actually while coming to implement, we will do hands-on. Okay, so you will get good understanding on how to implement those things. Okay, so while we are discussing hands-on, we will discuss in depth. Okay, how to use local executable provisioners and how to use remote executable provisioners. Okay, and how to use creation time and destroy time provisioners. Now we will discuss about failure failure behavior for provisioners. 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 Okay. On failure argument we have to use on failure. This is the argument we need to use. What it indicates is how Terraform is this. You can define something is failed while you are using remote executables or local executables. How Terraform need to respond that fail, that you are the one going to declare. It indicates what I can say. It determines. Okay, it determines how TF responds if a provisioner fails. You can define that fails. Okay, there are two options there for us to handle this scenario. One is you can continue even if it is fails, we can continue. Second option is fail. The thing is, if you use continue, then Terraform ignores the failure and continues with the plan what we have written. Fails means Terraform stops the execution if the provisioner fails. Okay, this only you can define with on failure command. Okay, so you can if you are mentioning on failure, Okay, on failure as equal to continue. If you are giving, then it will do these things. If you are doing, if you are giving as a fail, then it will do this. Okay, so while coming to use case, failure behavior. While coming to use case, you can use fail for critical provisioning. Okay, for critical provisioning steps where failure impacts resources functionality. Okay, because otherwise there is no use of creating that resource. Okay, okay, or you can use continue when is for non critical actions like logging or optional configs. Okay, you can use continue. Okay, this is a thing you need to do. Okay, so while coming to key recommendations while using provisioners, key recommendations. You can avoid overuse. Overuse means provisioners are last resort. Use Terraform native features or dedicated configuration management tools like Ansible whenever possible. Second is error handling. Like properly configure on failure as we discussed. Okay, to prevent unintended disruptions. Third one is debugging. Use logs and debugging tools to troubleshoot provisioning issues. Okay, so these are all the things you need to.
Hello, Kishore.
Yes.
Yeah, come here. So, yeah, I wanted to ask for this help. Like when I was doing the lab, right? So it showed like it's showing me some error.
What error?
Can I share my screen?
Yeah.
You see this?
Actually, you need to add your SSH keys, like not SSH, access and secret keys. Have you done that?
Yeah, I have done that.
Scroll up.
Like previously I did. This is today I tried again.
Scroll
Earlier,
down.
like 2
Just
days
wait.
earlier, I added all the access keys.
Okay, just are you able to create a EC2? EC2 also is showing as not authorized.
Yes,
Okay,
yes.
like can you show your access and secret keys?
Can you see it?
No, I am asking you to show that in your server, not on a notepad.
Acha. How, like, what is the command for that?
Actually, type cd space or dot dot.
And
Click enter. Like a type ls space hyphen a and click enter. Okay, you can see .aws folder, right?
yes,
Open that.
what is the command for that?
cd space. First, you need to learn Linux and AWS. Okay, so that is must. Space .aws. Okay, now type ls and click enter. Now use cat space credentials. Click enter. Okay, just check whether your access and secret keys are correct.
Those are correct. I have copy pasted directly.
Okay, it is showing your API error. Okay, so go to your IAM. Click IAM. Scroll down. See, you don't have any policies, then how it will work? You should set permissions, right? Without setting permissions, how it will work? We have created one user called IAM. Better you can do with your root user, right? Like while I am showing you demo, I have done with root user only, right? So first you need to learn AWS, like how to configure it manually. Okay, after that only you need to learn Terraform. Okay, otherwise it is difficult to understand both. Okay, just go to your user instead of IAM. Go to root user. How you are logging in with IAM or with your own user?
With root user, I am logging in AWS.
Okay, just click users.
This is the users.
No, again click that users. It is showing only one user. Where is your root user?
In the demo, like this was
Okay, no
only
issues.
users.
Okay, what you have to do is you need to allow permissions to this IAM. Okay, if you do that, it will work. Okay, just try, learn and do how to use IAM and all. Okay, this is Terraform class, not AWS class. Okay, so
Okay.
just what I'll suggest you to do is just try to learn about IAM and try to
Okay.
create create a service. Okay, if you want to make it work, I can do it now itself, but you want to I am expecting you to learn. Okay, so when I'm doing this, just try. Okay, today learn IAM and how to add permissions, this and all learn. Okay, how to add policies and how to add permission. Okay, add required permissions. Okay, for Terraform. So if you
Okay.
do that, you can fix that IAM issue. Okay,
Okay. Okay.
if you are still facing issues even tomorrow, then I will help you to set up it. Okay,
Okay. Okay. Yeah, will do. Will do. Yeah.
okay, anyway you tried, that is good.
Thank you.
I don't know like how many of them tried, but you tried, right? That's good. Okay, just try to spend some time on Linux and AWS. Okay, it will help you to get jobs soon.
Yeah, will do.
Because DevOps is a combination of cloud provider, Linux. Okay, so you must be familiar with that. Okay, as well as DevOps methodologies and DevOps tools. Okay, so DevOps is a version. Okay, so spend some time on each day on learning all these things, so you can easily get job. Okay, let's start. Just give me a minute. I'll open syllabus and other things. Today we will have practical sessions. Okay. Madhu, you joined with your laptop only, right? Are you speaking?
Yeah, Kishore, it's audible.
Yeah, audible. No audible.
Yeah.
You joined with your laptop, right?
Yeah, Kishore.
Okay. First, we will discuss for half an hour. We will discuss some theory part. After that, we will move into practical. Okay. First, we will check what and all we have completed last class. So we will get some idea. Okay, actually, we will do hands-on first. After that, we will do, if time permits, we will look into practical things. Because let me share my screen. Last class up to provisioners we have completed. See, last class, we have completed up to provisioners. So what we will do is, here some things are not we learned how to maintain our infrastructure, Slack functions, and all we have discussed, right? So here the major topic we have covered last class is Terraform provisioners. right? So we will have hands-on up to this now. Okay, first we will have hands-on. Okay, if we have completed hands-on quickly, then we will focus on Terraform modules. Okay, so up to this we have completed, right? Just Madhu, can you share your screen? I
Yeah,
think screen control is not there. I'll just call them and I'll check with them. Okay. If not, I'll guide you. You do. Okay.
I can give the control. Right?
First of all, here there is no control button. That is the issue. I'll speak
Okay.
with them. Just give me a minute. Okay. Like I think control is disabled. I don't know why. He told he will check. Okay. Let's start. Type ls and click enter. Now Terraform practice 2 is there, right? Just open that. Yeah. Okay. Now in right side top, click a code in the top. After like a search icon, you can see one symbol, right? Just click that. Left side. No, no, not there. In the left side, last, like, yeah, click that. Yeah. Here you can see Terraform practice 2 folder, right? Just open that. Okay. Now we are going to learn about what and all we have discussed in last class. Okay. So like again, we are going with EC2 and S3. Mostly we will learn all our topics that what and all topics we are learning in Terraform that we will use with EC2 and S3 only, because everyone know EC2 S3. Okay, so remaining services and all, it will be purely AWS. Some of you may not know that, right? So for that, okay, as well as this is not an AWS class. Okay, it's fully focused on Terraform concepts. Okay, so that's why. Okay, here now we are going to learn about provisioners. Like last class we learned, right? There are two modes are there in provisioners and two types are there. Okay, while coming to two modes, creation time provisioners, destroy time provisioners. Okay, and while coming to two types, local provisioner and remote provisioner. Local provisioner means, for example, if you are going to create EC2 machine, okay, and you have written output file, okay. Last hands-on we discussed about outputs and we have implemented also, okay. Just click Terraform practice. I will show you the that output folder. Don't close this, okay. Open this also. Open that. Yeah, yeah. What it will do if I want to print my instance detail after its creation, then I can use output, right? For example, here we have printed instance ID, like that we can print public IP, anything that we need, right? So what it will do, it will show us the output after execution, right? So if you want to store that in a file, okay, where you are running those commands means, you can use local provisioner and you can write all these data in the file. Okay, remote provisioners means like user data. Last class we discussed it, right? For example, if I am manually creating an EC2 instance, okay, so what it will happen if I want to execute predefined commands, okay, once my mission is once my mission creation is done, by default I need to have like Nginx, Apache, this kind of softwares, Java and all. So what I will do, I will use user data and I'll provide all the commands that I want to execute, right? So the same thing that we will do with remote provisioners. Using remote provisioners, what you can do is after creation of service, if you want to set up set up or configuration, if you want to set up or configure any tools, then we can do that. Okay. Now in this answer, what we are going to do is we are going to create an EC2 machine. After creation, we are going to install some softwares. Okay, that is the concept. Here we are going to use remote provisioners. Additionally, we are going to discuss about how to use your existing key pair. Last time while we have created our machine, it is created new key pair. Okay, so I hope it's created new key pair. I'm not sure. Okay, so for example, you have 10 key pairs, but you have to use the specific key pair. Then how you can use that? That and all we are going to discuss. Okay, so just click under Terraform practice to click EC2. Okay, here you can see first what we are going to do. We are going to create an EC2 machine. Okay, like AMI, I haven't given any details directly here. You can use open variables.tf. There you can see AMI ID of my instance, right? Second one, line number 8, you can see I have declared my AMI. The best practice is while you are writing variable, you have to describe it. So if you are working with a multiple people, they will easily understand that what you have done. Okay, here you can see like in description, AMI ID to use for the EC2 instance. I have clearly written right in line number 7. First we will discuss about variables. So while we are discussing about EC2, it will be very easy. Okay. So first you can see first variable I have used for instance type. Okay, and I have given default value was T2 micro. So I need to like I am going to use T2 micro instance only, which is under free tier. We don't need to pay for that. And I have given description as type of instance to create. So while creating EC2 machine, I am going to use this instance. I'm just like mentioning it. Okay. After that, I am giving AMI details. Okay. I have created one variable called AMI underscore ID, and I have given the details. After that, you can see variable bucket name. Okay, since I am going to create an S3 bucket, I have given description, okay, and I have given default. Okay, default is my bucket name. Defaultly I am going to create a bucket with this name. That's it. Okay, here you can see I am defining my key pair. I have mentioned the key pair. Okay, ensure this key exists in your AWS account. We have to change the name of our key pair. Just go to your AWS account, see your key pair name and update it accordingly. Wait. Here itself, just to scroll this right side, you can see one. No. In the top, we have one instance, right? So bottom of that, you can see sliding button, right? Yeah, use that and not that sliding button, horizontal sliding button. You can see in the top. Yeah, do that. Here it will show you. Yeah, copy this and paste it in the code. Like that, while you are practicing, then you have to use yours. You just paste that. No. You have to use control V. You can use and paste. Yeah. Okay. And the description also I have given the key pair name for SSS to access EC2 machine. Okay, for example, if I want to connect that EC2 machine, I need PEM key, right? So, like what I'm doing, instead of creating new PEM key, I am going to use my existing PEM key. Like even 2 classes before we discussed, right? We can use existing PEM key also. That I will let you know while we are doing hands-on on the time, like this. I said, right? This is the okay. So just remember this. After that, you can see I have used some extra tags for S3 bucket. Okay, like project as a Terraform and so on, and the key as a team and value as a DevOps. I just added some extra tags for my S3 bucket. Okay, scroll down. Okay, variable. While coming to VPC, here I just written something for VPC, but we are not going to create a VPC. Okay, just I have created one variable. That's it. Okay, just to use that in my security group. Okay. So this is all about. Now, if we go to yes ec2.tf, you will understand what and all things we are doing. Like first, you can see we are using resources type as AWS underscore instance, and we have given local resources name as web server. And in while coming to AMI, we just called from variable AMI underscore ID and like instance underscore type. Okay. And you can see even tag also. I just given this as my EC2 instance. Okay, and I am going to attach the security group also. So like I just mentioned the security group that I need. Okay, so scroll down here also you can change that key name. Okay, just use the key like copy paste that key name. No, key name in the top, PEM key name. Line number 12. Yeah, okay. Now provisioners. Okay. In provisioners you can see remote underscore exec line number 15. You can see here it clearly shows that we are using remote executable. Okay, if you are remote executable provisioners, if you want to use local provisioners, then you can mention local underscore like a local hyphen exec. Okay, so we are here. What is our aim? We are going to create a EC2 machine and we need to configure some softwares. So we are going with the remote provisioners. Okay, in the connection you can see type SSH. I am going to create a machine which is Ubuntu based. So I am just mentioning Ubuntu and the host self.public IP. Once instance is created, I need to use that public IP of that machine. So okay, to connect. Okay, and I have given some time out. Okay, it may take up to 5 minutes. Okay, so inline you can see. The thing is, I said right, we have to first we have to create this server. After that only we need to install. In first block it will try to connect. Okay, once instance is created using host information, user information, it will try to connect. Once it is connected, actually we will it will take at least 1 minute, right? Like whenever you create EC2 machine, it will take at least 1 minute to boot up. Okay, so only I have given sleep time as 60 seconds. Okay, so what it will do, it will wait for 60 seconds and it will execute the below commands. Okay, otherwise, before, the thing is, before, if it is executing these commands, obviously it will fail. Okay, so only I have given time as 60 seconds. In real time, you can give seconds according as per your need. Okay, after that, line number 25, 26, you can see I'm just want to install Apache on my newly created machine. Okay, and I want to start it and I want to enable it. Okay, this is a purpose of those 4 commands. Okay, here you can see I have used local provisioners also because you need to have an idea of local provisioners, right? So once my machine is created, it will store that IP address under EC2 public IP.txt file. I have given one text file name, right? It will store my IP address in this name. Life cycle, create before destroy. I have given as true. So what it will do before destroy, before destroying, like it will execute this command, because after destroying there is no use of executing it, right? Again we can see I have written a code for resources definitions for security group also. Okay, here you can see I am giving resources definition as AWS underscore security underscore group, and name as web underscore sg. My resource like the security group name as web underscore sg, and I just give one name, description, my VPC ID. Okay, this and all you need to give as a runtime input. Okay, so like that I have come. Increase control. That is your inbound rules. Here you can see I have allowed port 22 anywhere IPv4, from anywhere IPv4. Okay, like that I have enabled port 80 also. Like that, for example, if you want to enable 10 ports, then you need to write 10 blocks like this. Okay, by mentioning from port and to port. Okay, here like egress means output, like outbounded rules. Okay, ingress means inbounded rules. Egress means outbounded rules. Outbounded rules always we will allow all traffic. Okay, otherwise we will not get out incoming, like our application will not be open to others. Okay, so it should be all traffic only. And you can see tag also I have given as web underscore sg. Okay, this is all about creating and working with the provisioners. Just go to s3.tf. Here also you can see first what we are going to do is we are going to create a bucket, and you can see prevent destroy equal to false. I have given, because if I want to destroy this, if I mention it as true, it will block me to destroy. So since we are practicing, I went with false. And you can see tags also. I have written one tag called my s3 bucket underscore 123 and environment as dev. Okay, and some extra tags you can see, right? In variables.tf files we have written some extra tags, right, like a team and those things and all that, and all it will be added here. Okay, after that you can see line number 18. We are enabling server-side encryption for better security. So when I have used AES256 algorithm, okay, it's purely AWS concepts that I have written as a code. Okay, after that you can see versioning also I have enabled. Okay, so it's a good practice to enable versioning. Okay, in S3, so I have written that. Okay, so these are all the topics that you need to know. So only I have created added all these things. If you are already familiar with AWS, then you know, otherwise you may not know, right? So I just written this. Okay, you can open providers.tf. Here you can see I am just going to use this version from Ashicraft to download the plugin. Okay, and my record version where I am going to create, I am going to create AP South 1. Okay, so I just specified my region also. Here there will be some issue will be there. Okay, that is your assignment. Okay, mostly I will not ask assignments whether you have done or not. If you want to improve yourself, you can do that assignment. Okay, first we will execute this one by one. After that I will let you know that issue. Okay, now type terraform space init.
Yeah, Kishore, it's executed.
Now do terraform validate.
Terraform format no need, right? Every time.
No, no. Validate means it will validate your configuration. If there is some syntax issue or logical issues, it will let you know. Okay, now do Terraform format, FMT. Just it will format your code. Yeah, it is formatted our ec2.tf. It's okay. That's good. Okay, now we will plan now. Okay, do Terraform plan.
But that format time S3 also need to come, right?
What's your problem?
S3 also need to come, right? S3.tf.
No. The
Okay.
thing is, if something is not formatted properly, then it will format. Okay, you
Oh,
can see
okay.
ec2.tf. It made some changes, right? You have to save that. Go to ec2 and save it. You can see in the dot, right? So it is formatted your code. If something is not formatted, then it will format. Okay, that is the thing. Do Control S.
Yeah, done. It's getting error.
Okay. Actually, just do Control C now. Because Terraform formatted your code, right? It is unable to save by easy like your code. Yeah, just do Control Z. We will go with our configuration instead of Terraform. Just do Control. No.
This
Just
one only we changed.
yeah, we changed it, right? Just re-update it. Just do Control Y.
Control Y is not working.
Control Z. Okay, just rename that.
Yeah. I'm changing. Yeah.
Now save.
Yeah, it's done.
Yeah, okay. Now execute Terraform plan. I think after adding that you didn't save it, you just executed in it itself. It's okay, no issues. We'll go with plan. Now it will ask your VPC, okay? As we discussed, just go to your AWS account, go to your VPC, don't go to your VPC, just go to security. Yeah, correct. Here you can see VPC ID. Scroll down. No, scroll up. Go to details. Here we will have security group only. Go to details. Here you can see your VPC. Scroll down. Yeah, you can see VPC ID, right? Just copy that. VPC ID. Yeah, just copy and paste it there. Enter. Now it has created plan for us. Okay. So just maximize your terminal. We will check. So what it will do, it will specify what and all details you have given. It will create one EC2 machines with the given AMI, and it will create one S3 bucket. Okay, and it will use your VP, like it will create security group. Everything it will do. You can scroll down. You can check and see. So what and all tags we have given, everything it will execute. Like it will show us. Okay. So now do Terraform apply. Now we will get some error. I hope we will check. We will get definitely, but not now. After some time. Again, copy paste your VPC ID. Yeah. Yes, type yes, okay, because you need to approve it. Just go to terminal. You can see this host. This will be your new machine's public IP. Okay, what's happening is it is trying to connect. Okay, instance has been created with the help of remote executable. It should connect and it should execute those commands. But the problem is, it is facing some issues while connecting. That's why it is retrying again and again. Okay, so you can wait even 2 more minutes. We will check. Okay, so it should once it is connected, then it only will execute it and it will complete it. Okay, but the thing is, it is facing some issues while connecting. Okay, that's why I said right one issue. Okay, we will wait for 2 more minutes also. Okay, it will try to connect, but it will not connect. Because there is some issue with our code. Okay, so like your task is I will not discuss this answer with you. Okay, because you have to fix this by yourself. Okay, once you are able to fix this, then you are great. Okay, so the thing is just creating writing some code and executing it will not help you guys. Okay, you need to think out of the box. Okay, so this ML code I have written, if you execute and if it is working, then what satisfaction you will get? If there, so only in this module I made some mistake. Okay, so your job is to identify that mistake, and after creation of servers you want to make if you are able to fix remote executable issue, connectivity issue, then it will connect and it will install the commands. Until then it will show this error only. It will not execute okay, it will not execute those commands, as well as this will not be a complete, it will not be completed. Okay, you will get this error only. Okay, So your job is to fix this. Just go to your AWS terminal, scroll up, you can see new instance has been created, my EC2 instance. This is our instance. Okay, but the thing is, while we are executing the inline commands, we are getting issue because we are trying to connect with it, but we are unable to connect. You can see in the logs, IP, it's clearly correct, right? 13.253, 232.3.251. You can go to Terraform terminal, it will show that as a host name. So IP and all I have given correct. I made one other mistake. Just go to terminal. Scroll up. Remote executable provision error. You can see, right? SSS authentication is failed. Okay, no supported methods. Okay, here bucket is already created because in our last project also we have given the same name, so we have already have that bucket. Like uh, I am taking Terraform classes for so many people, right? So someone created that bucket. Okay, in S3 bucket name should be unique, so only it is showing bucket already exists. Okay, I think one of my students executed this, and so it is showing for us. If you can use, if you change that bucket name, it will work. Okay, S3 will work perfectly if you change bucket name in the variables.tf. Okay, in the variables.tf you can change the bucket name, it will obviously work. Okay, but while coming to remote, your task and assignment is you have to fix the remote executable provisioner error. Okay, save this. Just variable file you have updated, right? Once you have updated, you have to save. Okay, just coming out from there, it will not help you. Hello,
Hello.
are you listening?
Yeah, yeah.
Yeah, you have to save that, right? You made some change in the bucket.
Yep. Yeah, done.
Actually, you need to have this habit. Once you made some changes, you have to save that and you have to come out of that. Okay,
Okay.
because in real time, if you forgot and if you do a play, then it will be a problem. Okay, so this is the task. Okay, I hope you guys know the assignment. Just copy that error, Madhu, and paste it in a chat box. Okay, this is the error you have to fix. I will not ask updates. Okay, because we are not sitting in college or school. Okay, so it's up to you. Okay, as well as I will not guide you on this because if I guide you, then you will just understand and you will go. You will not think. So you have to fix this, which is very simple. Okay, so this is all about today. Okay, now we will discuss about some other topics. Okay, okay, that we need to cover periodically. Okay, if time permits, if you are able to complete the theory concept today, tomorrow also we will have hands-on. Otherwise, tomorrow will be also theory class. Okay, uh, actually 1 hour was completed. We had practical sessions. Now we will discuss about another topic. Okay, better you can destroy Madhu while you are
Okay.
practicing, and other you can use any other server. Okay, don't do anything with this. Okay,
Sure.
otherwise if you are doing, then revert after this class. Okay, because again we will do hands-on with another project in upcoming days.
Okay. Sure.
Just do Terraform destroy. Okay, it will terminate that new instance. Click enter. Okay, we will start our next topic, and we will discuss that even tomorrow. If time permits, tomorrow we will have hands-on. Otherwise, next Saturday we will have hands-on. Okay. So, is there any doubt on this hands-on? I hope you are clear. Is there any doubts? Okay, if there is no doubt, then we can proceed. Let me share my screen. Are you able to view my screen?
Yes.
Okay. Terraform modules. Our next topic that we are going to discuss is Terraform modules and workspace. Okay. Let's discuss. Any idea about Terraform modules? Why we may need it? Any idea? Let me know if you know anything. Okay, let me explain then. Since you people are not telling anything, I hope my screen is visible, right? Just let me know if not.
Yes, yes.
Okay. Terraform modules. Okay, what are modules first? Okay, modules actually, the major reason for using modules is to reduce the uh, number of lines in the code as well as to reduce the resources definitions. Okay. If I want to tell this as a definition, actually we will use models for containers. Models are containers for multiple Terraform resources grouped together for reuse and organization. We will use modules for reuse and organization. Okay, like what modules offers us. Okay. While coming to uh, like advantages, it's a simplify our configuration. Okay, it will simplify our complex configurations. Okay, it will enable reusability. Across different regions, across different environments or like not regions, mostly you can say as environments. Okay? Like it will promote right principles. Which indicates don't repeat yourself. Okay, these are all the advantages it was provided by modules. Okay, so if you use modules, so we can reuse the code. Okay, instead of writing the code again and again, we can reuse the code. Okay, that is the best example, the best purpose of module. Okay, example of module, how you can create a module. Okay, your folder structure is important here. Okay. Okay. Here, like how you can write this, you can create one folder called modules. Under that folder, you can create one folder called EC2 instance. Under this like folder, you can write main.tf, variables.tf, outputs.tf. Okay, after that, you can have like by calling this path, you can have your main file .main.tf. Okay, this should be the folder structure. Like this only we have to create this structure. So you can ask. Okay, so then now I can write my infrastructure like that. You can ask. For example, it will be here. You can see modules EC2 main.pf, right? So how I will write code for this? How I will write? Okay, just we are simplifying the code. Okay, we will call. We will declare the modules and we will call the modules. Okay, so now I'll write code for the path modules slash ec2 dot instance slash main dot tf. Yeah, the same only like previously what we have written, the same thing only I'm going to write. Like resources type, we will declare AMI and in a variable only I am going to call my instance type also. Again, I will like you if you need, you can write output code. Okay, so like outputs instance ID like my resources type dot local resources dot ID. Okay, this is my modules dot ec2 dot main dot tf. Okay, now I will write code for variables dot tf. Same only instead of this we will use variables. Same path variable. Okay, like in AMI, I'm going to declare it as AMI, and I'm not going to give any default or anything. Okay, so I'll just use this curly braces and I'll close this block. Again, I am going to create one more block called variable. Here also I'm going to give it as instance type. Okay. Now I have declared, I have created modules for my instance.tf and my variables.tf. Right. Now I am going to write the main file. Okay. Main file is just simple. Okay. Just we are going to specify our source. That is enough. Even let me write and I'll show you. Here I need to use module, and here we have to mention the folder name where we have our module. Okay, our folder name is ec2.instance, right? So we have to provide that folder name ec2 underscore instance. Here we have to provide source. Here what I have to do is I have to provide my module path. Okay, from here this is the path, right? So I'll just copy this. I'll paste this. So this is my source. Here you can see I have not declared anything default, AMI or instance type. Okay, so I have to mention here. Otherwise, just mentioning this is enough. It will take everything. Okay, not variable subject, only your instance folder. It will take everything. But the thing is, I have not given AMI or instance type, right? So I have to manually add those things. AMI. Even this also you can call from modules. Okay, instead of writing, I'll just write it. Okay, by using this source path. Okay. Okay, like that I can write. Okay, this is how you can instead of writing resources definition, you can use module and you can write it. Okay, instead you don't need to specify even this also. Okay, if you are creating a module. Okay, since I have not created, I just call it. Okay, we can like the major reason is we can better organize the resources and we can enhance team collaboration. Okay. The second one is understanding bright principles. Okay. Like while coming to bright, we are going to discuss, right? Don't repeat yourself principle. Focuses on reducing repetition in code. Okay, which uses modules to avoid duplicating resources, duplicating resources definitions. It will leverage variables to parameterize reusable modules. Okay. Without trying, you have to write like resources definitions, and you have to specify everything. Here within the module, with the help of the module, you can avoid resources definition, and you can use source, and you can call the path, and you can reuse it. Okay, that is a major advantage. Like that only we are done with implementing EC2 module with the Terraform. Okay. So, like if you are using variables, you can declare accordingly, okay, and you can give the path. Okay, we will have hands on for this also. Okay. Another one is like you need to know here is Terraform registry. Actually, Terraform registry, it's a it will host publicly available modules. Okay, it will enable reuse of community built-in modules. Okay, if you need community built-in modules, it will host publicly available models. Okay, and we can reuse this. Okay, mostly in companies we will not use public model that was written by someone, or we will not use GitHub. From GitHub also we can clone Terraform models and we can use. From Terraform registries also we can clone and we can use. But in real time, if you are working in a company, we will write our own modules. Okay, by defining structure like this. Okay, by defining structure like this, we will create our own modules and we will write our own code according to our need. Okay, we will not use Terraform registry and we will not do copy paste. Okay, Terraform workspace. Okay, actually Terraform workspace isolate store isolate state files for different environments. The thing is, if you are working in a company, okay, there are dev environment is there, staging environment is there, production environment is there. You need to use one code, but you need to maintain different environments. Then you can use Terraform workspace. Okay, so what it will do, it will create separate state file for dev, stage, and prod. You can use a single code, but it will create different state files with different environments. So one will not merge with another. Everything will be isolated. How you can create workspace with the help of Terraform workspace. New dev. Here new is the name, dev is the environment name. Okay. How you can switch workspace here? If you want to switch workspace, you can use Terraform workspace, and you can use select, and you can give your workspace. For example, you have workspace for stage also. Then if you want to switch from dev to stage, then you can use stage like this. Okay, this is how you have to switch. Even you can list the workspace, how many workspace we have with the help of Terraform. Terraform will be in small letter. Okay, Terraform workspace list. It will show you the list of the workspace that you have. Okay. Next is remote state management. Is there any doubt till now? Can we move further? Hello. Guys, please let me know.
Yeah,
What
teacher.
month? If
You
you
can
need,
move on.
we can have 5 minutes break. Okay. So now time is 3:20, right? We will start from 3:25. Okay. Don't leave the meeting. Just be in the meeting. After 5 minutes, we will start. Okay, we can carry on. Okay, next is remote state management. Okay, remote state management. Actually, the major reason for using remote state management is remote state allows multiple team members to access and manage shared Terraform state files. Okay, for example, we will have our state file in local, right? Uh, for example, multiple people working in a project. Okay, so we need to collaborate. Then we need to have state file in common place, right? We can store our a state file on GitHub because we will have sensitive informations. Okay, if you are using GitHub, it may expose. Okay, so what we can do, we can in our AWS account, we can create an S3 bucket and we can store it there. Okay, so and we can give permissions only those who need it, right? So we can enable the collaboration. So how you can write that backend is like using Terraform backend S3. Here we can mention our bucket name. Okay, like my TF state folder, like that anything. Okay, and I am giving yes path of my state file. Okay, like just a state like Terraform dot TF state. Okay, this is the key. Okay, that is my exact path of my DS, like my state file, and I have to specify region. In which region I am storing this bucket. Okay, like I will give it as AP South one. Okay, this is how you need to write the backend file. Okay, so what it will have, it will enable collaboration. Even if someone deleted a state file in the local, they can fetch it from uh, S3 bucket. Okay, this is one of the best practice. Okay, next one is while you are integrating Terraform with Git for team management, some of the things you need to focus. Okay, that we will discuss. Integrating with Git for team management. Okay, like using this, what you can do is you can store TF configuration files in Git for collaboration. Mostly, we will store our code on GitHub, but we should not push some of the things. We have to avoid committing state files or sensitive data. So, what and all sensitive data we will have in Terraform, and what and all we should not push, that we are going to discuss. First one is Terraform state file. Terraform.tf state, and you should not backup Terraform.tf state dot backup also. By default, Terraform will create these two files. Okay, for example, this is the original file, this is the backup of this. Okay, Terraform itself by default it will create the backup file. Okay, for example, if you remove this, what you can do, you have removed but you have this, means you can rename this to Terraform state file. So while you are doing next apply, it will create backup again. Okay, why I am asking you should not push this to GitHub, it will store all the sensitive information like instance details, IP addresses, everything end to end. What and all resources you are creating, it will store all details there, access keys and secret keys and all. If you are pushing this to GitHub, it may expose. Okay, that's why. Okay, so that's why we should not push this. Then how you can handle this is while working with Git, you can create one file called Git ignore. Okay, you can add these file names in the Git ignore. So while you are pushing, it will ignore. Okay, so you will not face any security issues. Okay, remember this, which is very important. Next one is security challenges in committing TF state to Git. Okay, as I said, access keys will expose, passwords may expose, state file exposure can lead to security breaches. Okay, so only we will not push that to Git. Okay, next is module sources in Terraform. As I said, you can fetch the Terraform modules from Git repositories, or you can fetch from Terraform registries, or you can write your own modules in your local directories. Okay, so these are all the possible ways. Okay, so the syllabus completed. Challenges in committing modules in Terraform. Okay, Terraform and Git ignore. Actually, everything what we discussed only they have mentioned it again and again. Okay, while coming to Terraform and Git ignore, as I said, we have to create a Git ignore file and you can add all the files. Okay, so it will not be pushed. Okay, implementing S3 backend, that also we saw, like how to implement it. Okay, challenges with state file locking. Okay, actually state file locking prevents simultaneous modifications. Okay, use remote state. Okay, to avoid state file locking. This we will discuss. Okay, challenges with state file locking. Okay, the thing is state file locking prevents simultaneous modifications. Let me explain this in detail. The thing is, okay, you and your colleague are working, okay, in the functionality. Okay, you are using S3 bucket, okay, but you don't have any state locking. Then you and your colleague hitting Terraform apply button at a time. Then, for example, 10 minutes, 10 seconds before that you have executed means it will start creating infra for you, right? If your friend doing Terraform apply after 10 seconds, then obviously it will not like current state will not be equal to desired state. So we will our state file will lock. Okay, so again we have to fix the issues again, one by one we have to execute. To avoid this kind of issues, what we can do is we can create one table in DynamoDB. Okay, and we will integrate that with S3. Okay, so what it will do is only one changes it will take at a time. For example, 10 seconds before I have done means until my operation is completed, my colleague cannot run it. Okay, so once it is completed, once my operation is completed, he can execute it. So we will not face state lock issues. Okay, so only we will use DynamoDB. Okay, you can integrate S3 with DynamoDB. That's only our next topic, integrating Dynamo DB with S3 bucket for state log, so we can avoid concurrent changes. Okay, so what the same function only what I have written for S3. I'll just add DynamoDB bucket. That's it. DynamoDB table. Here I will create one more parameter called DynamoDB underscore table, and I will mention my table name. So what it will do, it will prevent concurrent changes on our state file to avoid state locking. Okay? This is the purpose of this. Okay? Because since I'm maintaining multiple class boards, I don't know what's so I think Terraform class, right?
No, Terraform hyphen board.
Terraform board.
Yeah.
Okay, then yesterday I have written a different board. Why no one is informed that? Okay, let me copy paste it. You guys need to tell that. Because I am having multiple boards. I think is this your board? Yeah, this is your board. You have to tell that, right? Okay, let me copy paste it. Okay. Now I have pasted the content of our yesterday's class. Okay. Yesterday, up to integrating DynamoDB with S3 for state locking. Up to this, we have covered. Yeah, up to here we have completed. Like today also, we will have theory class. Okay, we will discuss about Terraform state management, importing existing resources with Terraform import, security premium. We have almost came to the end. Okay, so what we will do is today, from year to year, we will have theory class. Okay, next class we will do hands-on. While coming to Terraform Cloud, actually, we will discuss only overview. Okay, Terraform Cloud, for that you have to pay for HashiCraft. You have to take subscription, and you have to pay for that. Mostly companies, they won't pay for anything. Okay, this kind of open source tool and all. So we will use what and all we have done in past classes. Okay, so mostly we will not use a Terraform Cloud. Okay, this is a managed Terraform services. Okay, provided by HashiCraft. Mostly we will not use Terraform Cloud. Okay, so we will just have a look at this. Okay, what is the purpose, why we need? So only in syllabus itself, they have given us overview. Okay, but next class, while coming to hands-on, we will deep dive into Terraform modules workspace and remote state management and security premium. Next class we will have hands-on on these things. Okay, next class will be your last class. Okay, while coming to Terraform, next Saturday your course get completed. Okay, while coming to Terraform, if you enrolled in any other courses, then you can do that from Tuesday, not Tuesday, like Sunday. Okay, next Sunday. Okay, let's start. Up to this we have completed yesterday. Now we will learn from Terraform state management.
Sure, can you share the screen?
Oh, okay, let me share. I thought I would share. Okay, let me show you again. Yesterday, up to integrating DynamoDB with S3 for state locking. Up to this, we have completed. Okay. Today, we are going to discuss from Terraform state managed to entire syllabus. We have only few topics on pending now. Okay, so while coming to Terraform Cloud and the enterprises capabilities, mostly in companies we will not use Terraform Cloud because we have to pay. Okay, even if you want to try, you have to pay. Okay, so as in the syllabus, we will only discuss the overview of Terraform Cloud. Okay, but what and all we have done in past classes and what and all we have learned, that only in real time you will use. Okay, so next class, okay, today we will cover everything theoretically. Next class we will have hands-on. Last class up to this we had hands-on, right? So next class, next Saturday, from Terraform modules workspace to security premium, we will have hands-on. Okay, next class. So next class will be your last class. Okay, because while coming to theory part, we will cover this today itself. Okay, this is all about syllabus and how we are going to group. Okay, Madhu, next class join without fail. Okay, because we
Sure,
will have.
sure.
Okay. Okay, then let's start today's class. I hope my screen is visible, right?
Yeah.
Okay, thanks for confirmation. Okay. I think 12 people joined. Okay, let's start. Terraform state management. Okay, is anyone having any idea about Terraform state management? Okay, let me explain. State management involves keeping a state file secure. Yesterday, while we are doing hands-on, I hope you saw terraform.tf state. That is the state file. Okay, that is very important. Without having state file, we can't do anything, because every time while you are applying command like terraform plan or apply or init, with the help of terraform.state file only, our current it will compare the current state with the desired state, and it will update the changes accordingly. Otherwise, it will not update properly, as well as it will throw you an error. Okay, so we have to keep our state files secure. And we have to ensure consistency. And we can easily handle state drifts also. State, what it indicates is manual changes outside Terraform. Okay, you are creating two EC2 machines on your AWS account with the help of Terraform. Your colleague is created one more machine, but instead of without using Terraform, he directly created it. So again, you are working with your Terraform code, and if you are planning and if you are executing, it will throw you an error, because your current state is not equal to the desired state, because your colleague is already made some changes. So you have to update the current infrastructure information on your state file, then only it will fix the issue. So what you can do, so you can use Terraform refresh command. Okay, if you execute this, it will review the current infrastructure and it will update the state file accordingly. So we can fix that issue, as well as, and you can even import the resources that was created by your colleague. Okay, to avoid issues, to avoid discrepancy in current state and desired state. Okay. Changes outside Terraform means someone is doing manually. of using code, then it will create an issue for us. So once you started working with the Terraform, once you decided to build your infrastructure using Terraform, until you complete that infrastructure, you should use Terraform only. Okay, for some resources Terraform, for some resources, if you are doing manual configuration, then it will not work. It will throw you an error. Okay, I said right, importing existing resources. How we can do that? Only we are going to discuss now. Importing existing resource with Terraform import. How you can do? With the help of command you can do. Okay, you can like what it will do is import allows you to create existing infrastructure that to be managed by Terraform without recreating it. For example, your colleague created one instance. Then how you can add that into Terraform CANC by using import method only. The command is Terraform import your resources type. My resources type is, since it is EC2 instance, AWS underscore instance, and local resources, and with ID of that instance. You have to mention that ID. Okay, so if you do this, it will import that resources in your Terraform infrastructure. Okay, so while you are creating new resources, these existing resources created by your colleague manually, it will not affect you, as well as it will be in your Terraform cache. Okay, you can fix issues. Okay, like if someone is manually changing the Terraform. Okay, so next topic is security premium. Okay, here we will discuss about what are the security precautions you need to have while you are working in Terraform, because if you are working carelessly, then it will lead to expose sensitive data. Okay, so in company data is very important. Okay, that is our infrastructure data is very important. Okay, if you are working in a company and if your access and secret key was exposed, then anyone can attack your AWS account. It will create huge loss for companies. So focus this. Okay, it's an important topic. Okay, so you have more focus on this. First one is handling access and secrets keys with the right way in providers. Even in while we are doing hands-on, we haven't directly added our access key and secret key on the provider.tf. What we have done, we just installed AWS CLI and we have configured our access key and secret key on .aws folder. Okay, so no one can't access it, right? The Terraform you can use that, but it can't expose it because we have that in the folder. Okay, if you are adding that in provider.tf file, then obviously it will be exposed. Okay, so let's discuss in detail. Actually, security is critical in Terraform configuration, as improper handling can expose sensitive data. Okay, while coming to key considerations. First one is we have to protecting state files. It itself will resolve 50% of issues. Okay, how you can protect state files? State files often contain sensitive information. Okay, such as access keys, credentials. So you should not push your state file to the tools like GitHub. Okay, because it may expose. Okay, you can store that in S3 with the least privilege access in IAM. Okay, using environmental variables. What it will do is it will you need to avoid hard coding credentials in .dfs. Use environmental variables instead. So only one thing you can do, you can go with the .aws folder as we done. Otherwise, you can import your access key and secret key as a as an environmental variable. You should not inject your access key and secret key directly in the code. Okay. You can use encrypting. Encrypting backend storage. How you can do? You can enable last class we have done, right? We have enabled SSC for SS S3. So and we have discussed about remote backend, right? You can store your files on S3 and you can enable SSCs. Okay, so it will secure you, as well as you can give least IAM privilege. Okay, for that bucket. Restricting policies. In restricting policies, we will discuss about that only. Restricting access. Restricting access means like you can use IAM policies to limit access to Terraform resources and backends. I mean your S3 bucket, because in S3 only we will store our state file, right? Okay, that's one. For example, how you can use environmental variable like that. If you ask any doubt, let me explain. First one is how to use environmental variable for AWS credentials. Now, what we have done in theory, like a practical class, also secure. Okay, since this is .aws folder is your one of the Linux folder, it can't easily expose. Okay, you can follow like what we have done in our practical sessions. Okay, apart from that, these are all possible ways. Okay, you can export using expose. Like the first method is AWS credentials stored in E&ICT. How you can expose is using export keyword. Export in small letters. Export, and you can define a variable with the value like AWS underscore access underscore key underscore ID equal to your key. Another one is export AWS secret access key. Like that you can import. It is secure. Otherwise, like the last class we discussed, right? Enable S3 encryption. Even we have done that in our practical, right? AES 256. Using that you can encrypt your packet. Okay. Next one is in the while coming to security. Next topic is handling access and secret keys. Handling access and secret keys the right way in provider. avoid hard coding credits as we discussed. Never include access key directly in your .df files. Okay, so you should use environmental variables only as discussed. Okay, otherwise you can use any other path. Okay, actually concept is same only. They are writing again and again the same thing. Handling this and all. Here itself it will like everything will come. Okay. Next is Terraform providers use case. Resources in multiple regions. Okay. Terraform allows managing resources across multiple regions by defining multi-provider configurations. Okay. You can use multi-provider configurations to achieve it. How you can do that only we are going to discuss. Like we know we can able to achieve it, then how we can with the help of allies. Okay. Let me write with an example. Now I am writing a provider code. Provider. I am using AWS as my cloud provider. This AP South one. I'm specifying my region. Okay. And while coming to region, actually here I will not specify one AP South only. In regions, what I'm going to do is I'm going to specify AP South one. Okay, this is one provider. Again, I am going to create another provider. Here, I am going to use US West. Here, I am going to use US West 2. Okay. Now, since I am using multiple regions, how I can create a resource? You may have doubt, right? So how you can create is while writing resources definition. Resource AWS instance. Now here I am going to create instance for Mumbai region. So instance, okay. So I'm just going to name my local resources as South instance. And I am in provider. Now only we have to work. In provider, we have to call this AWS with our alias name. AWS dot our alias name is AP South. So you just call them. Okay. Now you can provide as usual, you can provide your AMI. And you can provide instance type. So if you want to create resources in multiple regions, you can use zipmap as we discussed in our previous classes, or you can use this alias method. Okay. Here the same thing only. Here instead of south, you can use west. So this is how you have to write. Okay. Next is handling multiple AWS profiles with TF provider. Actually, you can manage multiple AWS profiles by specifying profiles in the provider configuration. For example, we have one profile called dev and another profile called prod. Then you can do the same thing only. what code we are the code we have written right here, the same thing only. Okay, here instead of using alias, we will use profile and my profile name is dev. Again here also I have to change, right? Profile. It will change. Okay, for multiple regions we have to use alias. For different profiles we have to use profile keyword. Here I mentioned profile as pro. Okay. So while you are doing, actually here also you can mention alias. Okay, it will not be the problem. For example, if I am giving the same thing with alias, just actually you have to give here alias also. Actually, by calling provider, we will use AWS and region alias name, right? Here, what we have to do is we have to specify AWS and our alias name. Okay, like AWS dot dev, same on AWS dot prod. Okay, this is how we have to define. Okay, if you are using multiple profiles. Okay. Next is Terraform and assume role with AWS STS. Actually, to assume a role, you can use the AWS STS. STS stands for Secure Token Service. Okay, with Terraform. Okay, like the thing is, if you want to IAM role to assume, then first you have to create an IAM role. Okay, and with the necessary permissions. After that, you have to attach that in your provider configuration. Mostly, we will not use this. Okay, so if you want, you can do it like that. Okay, you can create with the help of AWS STS, you can achieve. Okay. Next is sensitive parameter. This is very important. Now coming to sensitive parameters refers to like SP refers to values like access and secret, access keys, secret key, passwords, and all. Okay, access keys, passwords, and so on. We have to use sensitive attribute. Okay, for example, you are going to create a variable. Okay, which consists password means now you can write variable name is DB password. You can write description as yesterday you saw, right? For each and every variable I have written description. The database password. Okay, in type I'm just giving it as string. Everything will be in small letters. Okay, insensitive. If it is sensitive, you can use this attribute sensitive true. Okay, so it will not expose this. Okay. So remember this. Okay. So even if you are writing an output file, you can use this sensitive as a true. Okay. So it will secure your password. This is all about sensitive parameter. Terraform Cloud and Enterprises capabilities. I think today itself we have time. We can complete today also hands-on. Okay. So we will complete our course by today because we have just Terraform Cloud and Enterprises account. Okay. And we will do hands-on and we will learn now itself. So today will be your last class. Okay. Terraform Cloud and Enterprises capabilities. Okay. While coming to this, actually Terraform Cloud and Terraform Enterprise provide advanced features for managing infrastructure as code at scale. Okay. It is specifically designed for teams and organizations that need enhanced collaborations, governance, and automation capability. Actually, what and all you can able to do with the Terraform Cloud that you can do with your AWS services also. For example, for security, what we are doing in normal, we are storing our state file on S3, right? So that we will use for team collaboration also. With the DynamoDB, we will enable state locking, so we can avoid concurrent changes, simultaneous changes on our state file, so it will not lock. Yesterday we discussed it, right? In Terraform Cloud, by default, it will have that feature. Since it is a cloud, Azure is providing cloud, you don't need to have S3 bucket, you don't need to store your state file on S3 bucket. By default, it will store in the cloud, so multiple people can work together and they can implement. Why companies are not using Terraform Cloud and Enterprise capabilities? They are already paying for AWS services. Okay, we will pay more for AWS services already. Okay, so companies won't pay again for something else. Okay, so there are so many features there in Terraform Cloud that you can achieve with AWS services also. Okay, creating one bucket in your S3, it will not charge more in AWS. Okay, but for Terraform Cloud, by default, it is giving, but we have to pay for that, right? So only we will not going with Terraform Cloud, we are going with Terraform itself. Okay, so we will use AWS services and we will do it. Since it is in our syllabus, I am just covering it. Okay, while coming to key features, remote state backend. By default, it provides remote state management. By default, it is providing. Okay, you don't need to do anything else. After that, VCS integration. It will seamlessly integrate with GitHub, GitLab, Bitbucket, and other resources for automated Terraform runs. But what we will do in Terraform, we will push our, we will do the same thing. Okay, so there is no much difference here. Okay, next one is policy as code. It will enforce governance using Sentinel. Okay, Sentinel also one of the paid service that that is one of the service available in Terraform Cloud. Okay, and the collaboration. Team management and access controls is very easy if you use Terraform Cloud. Cost estimation. Provides a cost overview before applying changes. Like the thing is that we can go with the AWS calculator itself. Okay, it's free to use. So while you are creating infrastructure without Terraform Cloud, then we can use AWS calculator and we will calculate the price for each service and we can execute apply. Okay, so everything is possible without using Terraform Cloud also. It will just reduce your work. That's it. Terraform tasks. It will automate the workflows and integrate with the external tools. Mostly if you are going to create a workflow, then we will use Jenkins. Okay, we will create workflows. Jenkins is a separate topic which will come under DevOps. Okay, so we will integrate Terraform with Jenkins and we will create the workflows. Okay, in general, here you can use Rentask to do it. Okay, next is overview of Terraform Cloud. Terraform Cloud is a ASIC managed service for running Terraform workflows. It simplifies infrastructure management with automation and collaboration tools. Okay, so the same thing only. These are not the features of it. Okay, so you can easily sign up with Terraform Cloud. You can integrate with VCS. You can create a workspace and you can apply the configurations here. Okay. Next is creating infrastructure with the Terraform Cloud. Okay, Terraform integrates with your VCS to automatically manage infrastructure. Okay, how you can create infrastructure in Terraform, like Terraform Cloud is, first you need to navigate to Terraform Cloud. Okay, and you can even build cloud pages. So first you have to do sign up. Okay, so once you done sign up, you can see how to like workspace, create workspace. You have to click create new workspace button and you need to connect with GitHub repo. Okay, just wait, I'll show you. Yeah, here you can see. Okay, you can click create workspace. Here you can see right new workspace. You have to click this. It will provide dashboard. Okay, since we are paying for them, they're just creating dashboard for us. Okay, if you click create if you click a new workspace, you have to provide your workspace name. Okay, and you should have your code on GitHub. Okay, for that you need to know Terraform. Using Terraform, you have to write the code and you have to push that, and you can clone that code here. Okay, so you can run it here instead of using commands to run here. You can run. Okay, that is the thing. Okay, anyway you have to write Terraform code. So only companies are not using it. Okay, because anyway we are writing code, we will use AWS services itself to do it, right? So, but few companies will use to reduce the workload, but mostly we will do with AWS services itself, services only. Okay. You have to provide your API token, this and all. This is additional work. Okay, so this is the Terraform diagram. You have to attach your GitHub and you have to run. You can see everything, cost estimation, everything in this code. Okay. So how you are triggering it? Okay, in states. Okay, how many triggers, how many applies you have done? It will show you how many runs you have done, how many resources you have created. Okay, what is the version of your Terraform? When is last updated? Okay, last updated changes time. How many resources you have created? Everything it will show in detail. For example, if you are using variables, then you can go to variable sections and you can add the variables like access key, secret key, AMI, instance type, everything you can set here. Okay, here we have to provide like name, for example, AMI, and you need to provide a AMI value. If it is sensitive, while you are writing code, you have to mention sensitive as true, right? Here you have to select this button. Okay, if you select this, then it will use that. Okay. So once plan is if you are doing Terraform plan, if it is finished, you can see logs here. And if you are clicking apply, like Terraform apply, then what and all changes it happened, what and all added, what and all destroyed, it will show. Okay, you can see the history of your applies and finishes. Okay, that and all you can't see if you are doing with the Terraform. See, it will clearly show your plan, everything it will show, but here it will show in UI. That is a difference. Okay. Next one is Sentinel. Actually, Sentinel is a policy as code framework. Okay, it's a policy as code framework. That integrated with Terraform Cloud and enterprises, it enforces rules and compliance during Terraform runs. Okay, when coming to its key feature, pre-apply enforcement, custom rules, built-in imports are not possible with Sentinel. Okay, the thing is, pre-apply enforcement means it will validate configuration against organizational policies before applying changes. Okay, you can write custom rules in Sentinel language. Sentinel is a language. Okay, so and you can do built-in imports. You can access Terraform data during evaluations. Okay, so you can write policies and you can do state locking, centralized state versioning. Everything you can do with Sentinel. Okay, so this is all about while coming to Sentinel and Terraform Cloud. Okay, so we will do hands-on on our topic now. Okay, like that we have discussed with like the security premium, remote state management, Terraform modules. So everything we will now we are going to do hands-on. Okay, because we have 1 more hour, so we can complete today itself. So next class, if you have any other courses, you can carry, right? So further. Okay. Is there any doubt till now? If there is no doubt, then we can go with hands-on. Madhu, can you share your screen?
Yeah. Is it visible?
It's loading. Yeah, it's visible. Like now type ls and click enter. Terraform 2 snap practice in Node. Okay. Just give me a minute. I will share you the repo. It is in another branch. Okay. Now this module I have created in another branch in my same repo. You will try to fetch it. Just give me a minute. I will share you the link. It will be under master branch. Just wait. I will share you the link. Oh, again, screen control is there. Let me access your screen now. I'll request screen control. Just accept it.
Yeah, done.
Yeah, okay. Just give me a minute. I'll be back. I am back. Where is the meeting over here, Teams, right? Okay, this is the code. Okay, now we are going to clone. Okay, yesterday we learned, right, that only here we have implement that I have implemented. Okay, let's okay, now we are going to clone using the clone. We are going to clone this. Just wait. Okay. Oh, still. Now we have cloned. Just give me a minute. I just left this. Okay. Since it is in the branch itself, we can easily check out that. Check out. Okay, I'm typing in my screen. Okay. Check out. Check out. Yes, totally. You made changes here. Okay, we will clone it as a new report. Okay, actually, I can't see your screen. Can you zoom it? Wait, otherwise I'll zoom here. Okay. Even I haven't like pushed it. Just give me a minute. Let me first. won't match. Let me check. I think you stop screen control again. Just allow it. Can you allow screen request?
Yeah. No, it's not getting.
Waiting for approval, it is showing. Just go to your Teams and check.
From. Can you request again?
Now,
Yeah, I given.
why you stopped it again?
No, I didn't stop. I didn't touch also.
Maybe it may have some time. Just wait. Okay, better do one thing. Okay, like here you can see, right? Where is Google? Just create this folder. Okay, this folder in your local. Okay, and let me know. We can start. Wait, where you can create is. Now you can see modules folder here, right? Where
Yeah.
it is.
Above snap.
Wait. Yeah. Now here, just recreate the folder that I have shared. Okay. Just add a copy paste. Just
Sure.
add all the folders and files. Okay, and let me know. We can continue. I have to merge. Okay. Like in free time, I'll just merge that.
Sure, I will check it.
No, I have shared all that already link, right? Just to open that link. Yeah, last one. Yeah, this is that one. Just create one folder called EC2 under module and add one more what other things that we have here. Just add that. What you are doing?
Trying to copy.
Listen. How you can copy it? You have to open the folder. You have to create this EC2 folder in VS Code and you need to add this file one by one. Okay. Better I'll add. I think you close this
I
VS
think
Code.
it's automatically closed. I didn't. 1 minute.
Just wait. Let me connect.
Second one. Yeah. So you open a new one.
Yeah. Hello. Just wait, okay? Let me do. Here you have to create that. How you can copy paste from there? Now you can add main.tf like this. Yes, it will be under main.tf. Okay. So just add the content by copy pasting. How you need to do is. So this is the main.tf. You have to copy this. Add it. Like that you have to do.
Okay.
Can you do?
Yeah, I will.
Yeah, okay, do it. No, not like that. Better wait. You are creating under EC2. You have correct only. Just
No, it's created new one.
Okay, now we have created three files in the EC2, right? Now
Yeah.
we have create under modules. Okay, so go to the GitHub. This is under modules. Okay, we have to store this file under modules, not under EC2.
Yep.
Yeah, like that. Add on this remaining files. Now here we have used module concept. Okay, we have written our own module, and we are doing this. You
This
don't
one
need
no
to
need
copy
or
paste. No
okay.
need, no need, no.
Okay, done.
Okay,
All of it.
okay. Let's start. Let me explain you one by one. Actually, here you can see like EC2, right? Under module you can see EC2 folder, right? That is the like EC2, right? That will be the root, like root modules. Okay, under EC2 you can see main, variable, output, main.tf, right? That and all root modules. Okay, so what we are doing is we are creating modules. Okay, and we are using that modules. Okay, while creating infrastructure. Okay, so if I click main.tf, here you can see I am calling the module from here. So this is these three files are modules. Now while I'm creating file, I am using that module and I am creating. Okay. First we will discuss about modules. After that we will discuss about our instance. Okay. This is main.tf module. Here what I have done, I just created one resources and I have just used variable to declare AMI, instance type and a key name and a security group and a tag. Okay. If I go to my variables.tf, here I have only two variables. One is tag and one is instance name. Okay. You can see here is my output. Okay. In output, I need instance ID and public IP as an output. This is my modules. I'm using these modules and I'm creating my infrastructure without using resources definition. Here in main.tf, you can see I haven't used any resources definition called resource, AWS underscore instance, local resources. I haven't used that. You can see what we have done here. We are just use module and our folder. Like here, I just named it as a EC2 instance. Okay, and we are calling our modules. Our sources, our modules, right? So I am calling that path. Okay, AMI ID. Again, I am calling AMI ID. Everything from the variable, security group, tags, instance name, everything I am calling from the variable. Okay. Uh, Only for security group, I have written the resource. Okay. Based on my workspace, it should choose the name. Okay. Like that, I have written. Increase my inbound rules, my outbound rules, and my common tag. Here, you can see provider.tf. Here, I just mentioned in this region, I need to create. Okay. And this is the version. Okay. In output.tf, I just I need instance ID, public IP, security group ID, right? So I just written as the code. Okay. And you can see variables here also. Here what I have done is, here I have just declared what are the tags I have given in my modules. I just declared that. You can see. Here just rename with your key pair name.
Yeah, done.
Have you added? Yeah.
Yeah.
Okay. So we are here also, like we have mentioned our tags like project, owner, everything we have just mentioned. Okay. So now we are going to execute this. Same way of writing only, but instead of writing as a definition, we have written as a module. That's it. Nothing else is the difference here. First, you have to do Terraform init. Init. Okay. Where it is getting rain.tm. Okay. Part of okay, this is the right path. We have to update that everywhere. Okay, now good. Now init was success. Actually, previously path was wrong, so throw us the error. Terraform validate. Our configs are valid. Now we will do Terraform plan. VPC ID. Just go to your AWS account.
Mm.
Yeah, paste that VPC ID. Scroll down, you can see. So in plan, it will show what and all it will do. Okay. Now we will apply it. Again, paste your VPC ID. Actually, while you are pushing to GitHub, you should not push straight file. Okay. That is the concept while coming to security premium. Okay, so you should not expose, you should not directly add your access or secret keys in the manifest file. Okay. Here you can see it has created and it is showing all the details. So just you can go to your AWS account, you can see the new EC2 machine with all these details. We have what name we have given is created with this. You can check cross check also 201 IP is ending with 201, right? Just go to VS Code. In the output, you can see the 71.201 code, 71.201 code with this SG. Okay, so this is how you have to create with the modules. Okay. So, is there any doubt? We came to the end of the course. Okay, so if you have anything else on your plate, just check with the coordinator and join in the course. Okay, so this Terraform board will be available. Okay, so you can use whenever if you want to revise. Okay, I will not delete that. Okay, as well as if you want, you can download that. Okay. So revise it, and while coming to Terraform concepts, it's everything. Okay, don't forget the concept. Just try to do what and all we have done in our classes. Okay, this is all about Terraform. Okay, if you have any other course, you can speak with coordinator and you can enroll in. Okay, okay, then thank you.
Kishore, 1 minute, Kishore. Good mind. Hello.
Yes, yes.
Yeah, yesterday you have given one task, right? To the server is not
Yeah,
accessing.
yeah, we fixed it.
Yeah. Just
How
I
you
have
fix it?
updated the private key
Okay,
and I saved the private key in the local machine, local Terraform
correct.
machine,
Perfect.
and it's executed. But as per the security trim, it is the recommended thing because we are saving the private key here, right?
No, the thing is, you are not giving your private key here, just giving
Okay.
path. Okay.
Okay.
So if you are pushing this in GitHub also, no issues. Everyone can see the path, but you have this like .sss folder on this server, right? So it can't be exposed.
Okay.
Okay, so no one can't what I can say. No one can't able to do anything with this. But if you are adding the private key in this manifest file, then only it will be the problem. Actually, there is
That means
just a small
uh,
issue. Okay, that only I said that you can easily able to fix. Okay, just mentioning file path and adding key itself, it will fix the issue.
yeah.
Okay, while you are
Okay.
pushing, see, I will show you this. Okay, log.hcl.
Here, right?
Yeah, that log.hcl, terraform.tf state. That and all you should not push. Terraform.tf.backup. Okay, this and all you should not push. Okay, so you can
Okay.
add these files on git ignore as well as just wait. I'll take your screen. Just allow it. I will show you what and all you should not push.
Yeah, done.
Yeah, here you can see this terraform.terraform folder, right? You should not push this. Okay, this one, these 4 things you should not push. Okay.
That means we can use that dot git ignore. That command we can use it, right?
Yeah, while you are pushing, first you have to create .ignore file. Okay, while you are committing it, you should ignore .ignore file. Okay, so what .ignore will do? Whatever files that you have added in .ignore, it will not consider that for push.
Okay.
Okay, so you can secure. The thing is, here you can see everything will be there, like your providers details, everything will be there. If you open terraform.tf state, let me show you. Or where is that? Yeah, we will open this. See here.
ID and
your security group ID. Okay, everything you will be there. Okay, owner ID. Okay, so VPC ID, your private key. See, your private key while you are giving name, it will fetch from there, right? So this is
yeah,
your private key. So that path will not like using that path they can't do anything, but using this they can do anything, right? So only I said, see, using this they can do anything. They can connect and they can do anything. Okay. So that's the reason. Okay.
and Kishore, do we have any practical
Yes, see,
related things while
instance ID and your public private IP. You can see your private IP, public IP. So this and all you should not expose.
yeah,
So now they have key with your public IP, right? So
yep,
it's not so only we are not like exposing it. Your volume, everything will be there. That's why we should not push this.
got it.
Okay, is there anything to tell or discuss? Let
Uh,
me know.
yeah, for practice furthermore, do we have any
What,
like
yeah, what you can do is uh, for practice, it's all about like how much knowledge you have in
yeah,
AWS. For example, if you know 20 services in AWS, what you can do is like only resources type, resources name will change and parameter will change according to that resource. So for example, if you are going to create route 53, then first you need to know about route 53 and what other components you need to know, need to have. Okay, so if you are going to create route 53 or if you are going to create secret manager, then go to Terraform documentation and check the what resources type we can use and what all
okay,
parameters we can use. Okay, so from there itself we can fetch. Everything will be there in Terraform documentation. Okay,
okay,
so
Kishore,
now you know the concepts and methodology. Just if you
okay,
know service, you can do anything.
got it.
Is there anything else?
Nothing
Is
from my
there,
end, Kishore.
okay, okay, then thank you all. All the best for your future endeavors. Thank you.
Yeah.
Start. Okay. Let me introduce myself. As you know my name, I am Kishore. I am currently working as a DevOps engineer. Okay, for a product company. And apart from that, in Besant, I am working as a DevOps trainer for past 2.5 plus years. Okay, so and I'll take Terraform also. Okay, this is one of the Terraform batch. Okay, so let's start. Since you people have joined Terraform, can I know for what purpose you choose this course? Why you are planning to learn Terraform? One by one. Okay. What
Hi,
is the
Kishore,
need for
this
you
is
to
Madhu.
learn Terraform? Okay.
This is
Yes.
Madhu, and I have an experience of 7 years of experience in Windows and VMware administrator. Uh, Recently, I have taken the cloud technology for the upgrade of my career. In here, Terraform is the main for the infrastructure for automation purpose. Nowadays, cloud, we are building the multiple EC2 machines or bulk of the configuration is going on. If we go for manually, means it is difficult. I mean, I'm talking about the administrative purpose. Terraform is for the multiple application. For that reason, I have taken the Terraform also in my course.
Okay. Is anyone else having answer?
Yes, sir. Myself, Prashant, and I was working in engineering college. So for career advancement, I have taken this cloud computing course. Terraform is as of as I think and as I know, computing infrastructure converting code instead of doing manually. So that much I know.
Okay, good. Like, are you working as a professor?
Yes, sir. So now I left the job and taking training
Okay.
in civil background. I want to shift from non-IT to IT.
Okay. Anyone else?
Hello, sir.
Yeah.
Yeah, this is Dinesh here from Chennai. I like cloud computing based on studied in my college second year, sir. So no, I know about the some basics, and why I choose this means I have to learn deeply about it.
What is a like? What will be your purpose? Like after learning this, where you are going to implement? Like that, I'm asking. Since most of you took cloud computing course, so you like, so you joined, or basically you have a need to learn this.
No, sir, I have basic needs to learn, not for a job. For my future, I can learn something from that, and that's it.
Okay. Anyone else? Like nearly there are 74 people out there. Only few people are speaking. What about others? I need to know your perspective also.
Yeah, good afternoon, Kishore. Myself, Kalyani. So I'm working as a project management role. So I just want to um, move to DevOps or a cloud related role. So I have taken up this cloud course here. So I said everyone said yeah, it's for automation purpose and it will make our work more efficient and easier. Yeah, very good.
Okay.
Thank you.
Anyone else? Yeah, you can unmute and you can talk Google.
Hi, sir.
Yes.
Yeah, my name is Karthik. I'm currently working for a TCS right now as a network engineer. So why Terraform? Like, I would like to know this multi-cloud support, like how Terraform is synchronization with AWS, Azure, and all. So right now I'm like doing on the on-site networking configuration, but I would like to like upskill myself. That is the reason like I've joined DevOps and at the same time like this Linux part and all.
Okay. Is anyone else having any idea?
Hello, sir. Myself, Preeti.
Yes, carry on.
Yeah, so currently I'm working as an Oracle DBA. So I have just joined Besant to upskill my knowledge. So I have taken cloud computing. So far AWS has completed for me and Azure classes are going on. So I just want to know like DevOps is also there in the scope. So I want to know like what is Terraform all about. Uh, yeah.
Okay. Anyone else need to talk? if you know Terraform well, and if you are able to handle any task with the help of Terraform, okay, you don't need to learn any other things. Okay, while coming to DevOps, okay, like just knowing Terraform itself enough, you can become infrastructure engineer in any company. Okay, there are more openings for infrastructure engineer. Okay, infrastructure engineer. If you know AWS services, that is enough. The only prerequisite is you should be familiar with AWS. Okay, if you are choosing AWS as a cloud provider, then you have to be familiar with AWS. Okay, this course is specifically focused on AWS Terraform. Okay, we can use Terraform. Terraform supports mostly all providers, all cloud providers. Okay, in this course, we are going to deep dive into AWS Terraform. Okay, the only prerequisite is you should be familiar with AWS. Okay, Terraform is an IAC tool. IAC means infrastructure as a code. Okay, instead of doing manual configuration on AWS account to create a virtual machine or storage account or creating database, we are going to write a code to provision it. Okay, instead of doing it with manual configuration, we are going to write a code and we are going to execute it and we are going to create an infrastructure. So the thing is, since you are going to automate the process, first you need to know how it should work manually. Okay, so the only dependency of this course is AWS. You should be familiar with AWS, otherwise you will not understand what I am going to cover. Okay, mostly most of the students, those who are joining, they don't have a complete picture. Okay, they are focusing on all the tools, okay, and trying for job and not getting job. Okay. The thing is, most of the companies nowadays, okay, companies has changed their plan. Okay, most of the companies now they are hiring what they need. For example, they need an infrastructure engineer. Infrastructure engineer also they will name it as DevOps only, DevOps engineer only. Okay, you will work under infra. Okay, creating infrastructure. Okay. For example, that will be need for them for Terraform. Then they will hire only for Terraform. They will not even ask you any other questions on Jenkins or Ansible. Okay, if they need a ISC engineer with the name DevOps engineer, okay, they will ask only Terraform. If they need a Kubernetes engineer, nowadays most of the companies instead of naming Kubernetes engineer, infrastructure engineer, they're naming as DevOps engineer. Okay, they will only ask you questions related to Kubernetes. Okay, so you have to fix the path and you have to learn accordingly. Okay, actually, while coming to DevOps is a version. There is no end for this. Okay, if you keep on learning each and every tool, getting a job is very difficult. So focus on one and get a job. Okay, if you're focusing on Kubernetes, then focus on a Docker first. Docker, Kubernetes, AWS, and try to get a job. If you're focusing on Terraform, then focus on AWS, Terraform, and get the job. That is enough. Okay, if you're going to enter into deployment engineer, okay, then focus on Jenkins, Ansible, AWS, and get a job. This is how you have to plan and work. Okay, only few companies that involve startups. Okay, they're naming as a DevOps engineer, and they will ask that engineer to work on all the tools. Okay, it will not help. Okay, yeah, mostly nowadays we have chat GPT, so many things are there. Okay, like just copy pasting something from there and completing your work, it will not help you. Okay, so focus on improving yourself on the specific part. Once you have done, then you can move into another. So this is my suggestion. Okay, the only prerequisite for this course is AWS. If you're familiar with AWS, then you can able to understand this and you can move on. Okay, mostly our course for one class we will have theory part and one class we will have hands-on, like that only we are going to work. Okay, so everyone must have AWS account and a Visual Studio Code. If you don't have Visual Studio Code, install it. Okay, this is the two things we need. Okay, it's a must, and everyone must join with your laptops. You should not join with your mobile. Okay, like as per Besant, if you are joining with mobile, then like I can able to if they know, they will remove it. Okay, I won't remove anyway. Okay, but they may remove you if they know. Okay, so it is better to join with laptop. Okay, as far as you can get better hands-on in laptop. Okay, and I hope everyone able to access syllabus, right?
Yes, sir.
Yes.
As I have shared one board, right? Everyone able to access, right? All are public only, publicly accessible. Anyone can link with this, can able to access it. Okay, let me share my screen. Let's first what we will do is first we will review the syllabus, and we will second I'll let you know like how we are going to walk around this syllabus, like in day-to-day basis, what we are going to do. Okay, this is the syllabus. I hope everyone have now. Okay, yeah. Just give me a minute. Okay, I'm back. Is my screen is visible?
Yes.
Yes.
Yeah, okay. Okay, this is the syllabus. Okay. Like first we will discuss about how to choose a right IAC tool, installing Terraform, choosing right ID for Terraform IAC development. Okay. Okay. Like ID we are going to use is Terraform. So not Terraform, like Visual Studio Code. Okay, Visual Studio Code only we are going to use to connect our servers. Okay, to work with the Terraform, and we must have AWS account to create infrastructure. Okay, what and all we will learn in this courses, like how to deploy infrastructure with the Terraform, how to read, write, modify configurations in Terraform. Okay, Terraform provisioners, Terraform modules and workspace, remote state management, security premier, Terraform cloud, like overview of Terraform cloud and enterprises. Okay. Actually, 1 month is more than enough to learn a Terraform. Okay, so this is 1 month course. Yeah, like every day we will have every weekend we will have 2 hours of class. Okay, per day. Okay, total of 4 hours. Okay, we will have. So this is more than enough to learn Terraform. Okay, like there are a number of IAC tools out there. Why we have to learn Terraform? The thing is, Terraform supports a number of cloud providers while comparing to other IAC tools. For example, Cloud Formation is there. Cloud Formation belongs to AWS. So, with the help of Cloud Formation tool, you can able to create infrastructure only with AWS. For example, your company is migrating from AWS to Azure. Then what you will do? You can't use Cloud Formation, right? So it will be a waste of time. Okay, in Azure we are having ARM. Okay, ARM templates to create an infrastructure. Okay, Azure Resources Manager. Okay, using that you can create infrastructure in JSON format. Okay, you can learn ARM also, but using ARM you can able to create infrastructure on Azure. Okay, but you can't able to create infrastructure in AWS, right? So we need a tool which supports mostly almost all uh, cloud provider without any issue, and it should be a widely used tool. The only one option is Terraform. Okay, it was made by ASICROP. Okay, ASICROP is a company who made a Terraform tool. Okay, it's a open source. Okay, only if you are going with the Terraform cloud, then only you have to pay. Terraform is an open source. It is free to use. You don't need to pay for it. Okay, Terraform uses HCL language. Okay, let me open my board. This date is 15 to 2025. Okay, Terraform uses HCL language. Okay, ASICROP or configuration language. Okay, Terraform uses HCL. Okay, it's not a programming language. Okay, it is like a, it is simple. Okay, it is like a common English. Okay, so we can easily able to work with HCL language. Okay, it uses .tf extension. TF stands for Terraform. So all files in Terraform is end with .tf. Okay, like a Terraform was developed by ASICROP. Okay, it's an open source tool. Okay, Terraform is an open source tool. Okay, now with our syllabus, we know we have chosen the right tool as a Terraform for AAC. We have to install Terraform that we will do on our hands-on class. Right, IDE. We are going to choose Visual Studio Code because it offers like you can able to connect your VM for free. Okay, if you are going with PyCharm, then you have to pay. Only 1 month is free. But while coming to Visual Studio Code, we have a plugin, so it is lifetime free for us. Okay, we need AWS account that you can create after this class. Okay, deploying infrastructure with the Terraform. Okay, before creating first EC2 instance with Terraform, we have to understand what is resource, what is providers. Okay, some theory knowledge is must here. Okay, like there are a number of things you have to learn here theoretically. While coming to Terraform, more than practical theory knowledge is needed one. The thing is, if you want to create an EC2 instance with the Terraform, you can even open Chat GPT and type, I need to create an EC2 instance with Terraform. It will throw you a code, right? You can copy paste that, you can create an infrastructure. But that is not case here. Okay, you have to understand in depth how Terraform works, why we need it, what is the purpose of resource, what is the purpose of provider. That is the only thing you should focus. Once you focus on that, while we are creating infrastructure, it will be very easy for us. So we have to focus on theory part also. Theory and practical both is a needed one here. Okay, like first we will discuss about resources and providers in Terraform. Okay, what is the purpose of resources? First, before learning resources, you need to learn about providers. Providers in Terraform. What is the purpose of providers? Providers in Terraform are plugins responsible for interacting with API of services. Example, AWS, Azure, Google Cloud. These are all the like a provider, cloud provider, right? AWS is one of the cloud provider, Azure is one of the cloud provider, Google Cloud is one of the cloud provider. Okay. What Terraform provider will do? It allow Terraform to create, manage, update resources on those services. Okay, what I can say, provider like provider is plugin responsible for interacting with APIs, API of service, APIs of service. Example, AWS. Okay, the thing is, how Terraform know whether you are going to create infrastructure in AWS or Azure or Google Cloud or any other platform. The thing is, in Terraform, we will have two components. One is providers and another one is resource. Provider, what it will do is, for example, you have decided to create an infrastructure with AWS. Okay, but you have to inform to Terraform, right? Yeah, I'm going to use AWS. So you have to create services on AWS like that. Then how we will do? With the help of provider file. While writing infrastructure, we will use provider file. Provider file we will create one file called provider.tf. In this file, we will tell that I am going to use AWS. Like that, we will tell under version what TF version I am going to use. Everything I will specify in the provider.tf file. Okay. I'm going to use AWS as a cloud provider. Okay, and TF version that and all you will mention. What it will do is actually we have one command called Terraform init. What it will do is it will initialize your current working directory. As well as it will set up backend configuration for you. So once you type Terraform init command, everything will be in small letters. Okay, it was auto corrected. It should be in small letters. All our commands should be in small letters. What Terraform init it will do is it will read the provider.tf file. Okay, in Terraform, while creating Terraform tool itself, they will trigger APIs of cloud providers, right? So it will read this TF file and it will check the cloud provider. If you are providing as a AWS, then it will use AWS API. Okay, and it will create the infrastructure. It will set up the backend config for AWS. Okay, as well as it will install all the necessary plugins. Okay, it will once you done a Terraform init, it will install all the necessary plugins based on cloud provider. Here, Terraform, like AWS, right? AWS only we are going to use as a cloud provider. So it will install all the necessary plugins that we need to perform all our operation. It will install all the plugins, okay, and it will Terraform know that now we are going to create an infrastructure on AWS, but there are n number of accounts are there. How Terraform knows to create infra on your account, right? Can anyone having any idea how Terraform knows that there are n number of lakhs of AWS accounts out there? How Terraform may find your account and create infra? Anyone having any idea?
Through access key.
Yes, access and secret keys. Okay, in IAM we have options to create, okay, access and secret keys. Okay, with the help of in your IAM user, you have to create access and secret keys. With the help of this access and secret key, TF will find and create info on your account. Okay, this is very easy, right? But the way you handle access and secret keys needed one. The thing is, in provider.tf itself, we can provide this access and secret keys. But if you're pushing that into GitHub, your access and secret key may expose. So attacks may happen. So while handling access and secret key, what you can do, you can store this, you can store it in variables as environment. where you are running TF. Okay, now we know, like with the help of provider only, it will choose the cloud provider that we are going to use. With the help of access and secret keys, it will find our account. Okay, so now we know how Terraform will choose the cloud provider, how Terraform will choose our account to create the services. Am I right? Actually, it will handle authentication. Like we need some authentication, right? If I want to access Terraform, like my AWS account, then I need like some authentication, right? It will only act as an authentication. My access and secret keys only act as an authentication, as well as it will help us to find our AWS account. Both it will do. Okay, so this is the purpose of provider. Okay, and Terraform uses CRUD operations only. Anyone know? Anyone having an idea about CRUD operations? What is CRUD operation? Can someone tell?
Is it create, update, read, delete?
Yes. Here also we will do the same with infra. We will create, we will read, we will update, and we will delete with the necessary commands. We have necessary commands for those, and we will use that to do it. Okay. Now we know about provider. Okay, example code how you can write a provider is we can store this file as provider.tf. Okay. Simply, if you want to write, then what you can do is you can mention provider as AWS and you can mention in which region you are going to create a server. If you want to create a servers in Mumbai region, everything will be in small letters. Okay, it is auto correcting it, so remember this. AP South 1 I can give if it is a Mumbai region. I can close this. Here AWS I have mentioned, right? It will take this as a cloud provider and it will create the resources on the in this region. This is belongs to Mumbai region. Okay, this is how it will identify it and it will create the region. Second one is resources. What is the purpose of resources? Resources represent infrastructure components that you want to manage, such as virtual machines, storage, networks, etc. Each resource has attributes and arguments defining its configuration. What and all we will call as a service in AWS, that only here we will call as a resource. Okay, which resources represents, simply I'll write, okay, for in future if you want to you can revise it. Resources represent the infra components you want to manage, such as VM. Okay, while coming to purpose, like we can define our infrastructure. Defining infra means like you can specify the actual components to create and manage. Okay, example EC2, storage buckets, S3, and you can define and you can create. State management. Next one is state management. State management is like resources are tracked in Terraform state file to, to detect changes and ensure that deserved state matches the actual state. Here, deserved state is your Terraform code. Actual state is your AWS account. It should match. Otherwise, like it will throw error while you are creating infrastructure itself. It will clearly tell that your desired state does not matches the actual state. So there may be some issues. So we have to work on fixing it. Like that only we have to analyze. Third one is dependencies. Dependencies. Resources can have dependencies on other resources. Okay. For example, for VPC, we need a subnet, right? So it has dependency on subnet also, our VPC. So enabling Terraform to create resources in the correct order. Okay. This are all taken care by resources. Okay. For example, if I want to if I want to create an EC2 instance, then what I can do is I can mention resources here, and actually in resources, this is a syntax for not only EC2, for each and every services. We have to mention the service name, okay, that we will call as resources type. Okay, here I am going to create an EC2 machine. Resources type for EC2 machine is AWS_instance. Okay, you can check Terraform documentation. They have detailed explanation on each instance type, and we have to mention resources. First, we have to mention resources type, and next we have to mention local resources. I'm just giving the name as example here. I'm just giving resources name as an example. Okay, and for example, if I want to create an EC2 machine manually, then you have to choose AMI, right? That only here you have to provide AMI. What AMI you are going to use? Everything will be in small letters. Again, I'm saying. Okay. Here, instead of selecting, you have to copy paste the AMI from your console. Okay, consider this is my AMI. Next instance type is needed one, right? What kind of instance type that you are going to use? Okay. Now I'm just giving ST2 micro, which is free, which is under free tier eligible. Micro, and I'm closing this. Now, if I execute this in a Terraform code, it will create an EC2 machine. Okay, but you have to do like you have to provide right AMI. Okay, here just for example, I have written this. Okay. Now, is there any doubt with in our resources and the providers concept? We are going as per our syllabus. Okay. Is there any doubt?
Sure. In simple manner, providers is connecting to the AWS. Which AWS it is respect? Sorry,
I can't
which
understand what you're saying.
providers mean it is a plugins which connecting to the which cloud like AWS or Azure, and resources are means inside the component.
Yeah, like resources you can simply compare with the services. EC2 is one of the service, S3 is one of the service, Route 53 is one of the service, right? That here we can call it as a resource. That's it.
Okay.
Any other doubts? Can we move further?
So I have one doubt. In AWS, we'll create key pair, right? In Terraform, we no need to create key pair.
No, how you can create a key pair of your AWS account in Terraform? It will not know, right? So the thing is, while coming to key pair, actually, okay, key pair. Actually, you can create a key pair, or you can use your existing key pair while creating a resources. For example, if you want to create a key pair, then you have to write a code for it. For example, if you are going to use your existing key pair, then what you can do is you can use your existing key pair name while creating resources. Okay, this and all still we haven't covered. Okay, up to what we have covered. If you have any doubt, you can ask. Everything we
Okay.
can create and manage here.
Okay. Thank you.
Even you can manage existing key pair here. Okay, like you can mention the name and you can fetch your key pair to create an instance.
Okay. Thank you.
And you can even create new one. Okay, everything is possible here. We will cover one by one.
Okay. Thank you.
Any other doubts? Like better what you people can do is like what we have covered, ask doubts from that, then when you will get familiar. Okay, can we move further? Okay, now we will learn the relationship between providers and resources. Actually, the major relationship between providers and resources is providers expose and define resources you can create. Next one is, for example, okay, if I want to explain this with an example, like AWS provider defines EC2 instance, like not EC2 instance, how it can define EC2 instance by giving AWS underscore instance. Okay, so AWS provider defines AWS instance to create a EC2 machine. Okay, if I want to create an S3 bucket, then I can use AWS underscore S3 underscore bucket. It defines to create an S3 resource on our AWS account. Only provider, okay, while they are writing Terraform code itself, they have defined like this. Okay, provider first it will choose provider from your provider file. Once it is chosen provider from resources, you connect with provider. Okay, so providers knows AWS underscore instance belongs to EC2 machine. AWS underscore S3 underscore bucket belongs to S3 S3 service. Like that, it will know. So while you are writing resources, it will communicate with provider and it will create the infra for you. Okay, this is the relationship between resources and provider. Okay, like AWS provider authenticates and communicates with AWS with the help of access and secret keys, as we are going to define that. Okay, that is only one authentication is enough to create any service on your AWS account. Okay, yeah, like just if I want to summarize this, like providers enable Terraform to manage resources on specific platform. Okay, this is the simply I can say, like providers, again I'm writing those who want to revise, enable Terraform to manage resources on specific platform. Okay, resources are the specific infrastructure components defined and managed using Terraform configurations. Okay, this is the thing that you need to know. Okay, is there any doubt? Actually, providers simply, as I said, which only download the plugin, okay, of your cloud provider, necessary plugins of your cloud provider. Once it's done, Terraform knows that you are going to create an infrastructure with AWS, so it will correlate with the resources name that you are giving with provider, and it will create the resources. Okay, this is the thing we will it will do. We know about desired state and current state, right? Desired state is, for example, if you have written code to create 10 EC2 instance, then that will be your desired state. Current state also, after executing the code, it should have 10 EC2 instance on your machine. Okay, if it is having only 8, then desired state will not match to the current state. So there is some issues we have to work on fixing it. We will go one by one. Okay, while coming to challenges. Okay, challenges. Challenges with the current state. Current state on computed values. I'm going very slowly. If you have any issues in understanding, just let me know. My ultimate goal is we have to understand. Okay, what is challenges in Terraform with the computed values? Okay, let me explain. Okay, challenges with computed values in Terraform arises because these values are determined only after applying the configuration. Computed values are marked as computed in resources schema. Okay, meaning they are unknown until runtime. Okay, example is I am going to create an AWS in AWS. I am going to create an EC2 machine. Okay, consider I am going to create an EC2 machine. Okay, so I am providing my AMI instance type. Okay, and I am even I am going to create a new key pair. So if I execute, it will create new key pair and it will create an EC2 machine. That's fine. But consider I am going to integrate my Terraform IAC with Jenkins CI/CD. How I can? My plan is once my EC2 is created, within the fraction of seconds, it should take the public IP of that machine, okay, and it should place that in somewhere, okay, something I am doing, okay. But the drawback in computed values is in Terraform, until you apply, you will not know the public IP or private IP of that instance. Okay, the thing is, first what command we will execute is Terraform init. It will initialize the current working directory, as I said. Okay, after that, what we will do is we will use Terraform plan. What Terraform plan will describe is once you execute this code, it will just create a plan. Okay, if you execute this code, it will create a 2 EC2 instance, 1 S3 bucket, like that. It will describe it. Okay, even in Terraform plan, it will not tell that your first EC2 machine public IP address. This will be your public address. Second machine's public IP address. This and all it will not show. Okay, it will just show tell that it will be 2 EC2 resources created, 1 S3 bucket will be created, like that. After that, if you want to apply this configuration, then you have to use Terraform apply. What it will do is it will apply your configuration and it will create the resources on your AWS account. It will create 2 EC2 machines on 1 S3 bucket. But the problem is it will not provide you the public IP or private IP or instance ID of few machines, your newly created machine. That is a challenge here. Since if we are doing manually, if we don't know, there are no issues. Okay, since we are going to do everything manually, but this is an automated code, right? Oh, the major reason for using Terraform itself to automate uh, the resources creation. Okay, for this only, Terraform has one more concept called Terraform output. You can write a output file, okay, while creating resources itself, and it will show this is your public IP, this is your private IP. It will show, obviously, it will show instance ID, everything by writing Terraform output file. Output resource, you can fetch details of that particular machine, details of VM. But what is the drawback here? It will not know until you apply. Until you apply, until it create, until it create resources or services in your AWS account, you can't know it. Okay, when you can know? Only after creation of resources only. You can know the details of VM. That is the challenge here. Okay, so like a dependency on apply time values. Okay, while coming to challenges, this is the major challenge. Okay, that I have explained. Okay, if if I want to explain this within technical terms, first challenge is dependency. Then see first initially I have explained with our local language, so you can able to understand the concept. Now I'll explain with Terraform keywords. Okay, dependency on apply time values. Until you apply, until the resources creation is done, you will not know the details of VM. That is the first drawback. Okay, some resources attributes depends on value that are only available after resources are created or updated. This can create complications when other resources depend on these computed values. For example, okay, if an output depends on the generated IP address or auto-assigned resources ID, it will not be known until the apply phase. Okay, that is a drawback. Okay, challenge is tools or workflow requiring this output in a planning phase cannot use it because the value is unavailable. Planning phase itself, if I want to integrate with the Jenkins or any other CI/CD tool, I can't do it. Only after apply, only after resource creation, only I can able to know the details of each resources. That is a drawback. That is a challenge. Next is planning. Planning limitations. Planning limitations is like we will use Terraform plan phase, right? To know what and all resources will create if I execute my code. But the problem is planning Terraform plan phase cannot provide a complete picture when computed values are involved. In this phase, we will not know, right? What will be my public IP? What will be my private IP? What will be my like instance ID. This and all we will not know in the planning phase, right? That is the issue. Okay, it will simply show unknown values, okay, in the plan, which can make it difficult to understand or verify the expected changes. Okay, this is a problem. While coming to impact, users cannot predict how Terraform will resolve these computed values, leading to uncertainties. Okay, third challenge is complex dependencies. Okay, why? Like, what is the complex dependencies in our current state of computed values? Okay, actually, the computed values, what I mean as a computed values is public IP of the machine or instance ID. That only I am meaning as computed values. Okay, because that values are unknown until it create. Okay, so computed values can cause unintended dependency chains that Terraform cannot resolve optimally. Okay, this may lead to issues like circular dependencies, delayed creation of dependent resources, increased complexity in resources graph analysis. Like example is resources A produces a value that resources B requires. Resources B also produces a value needed for resources C. Here, complexity will be in the like we will have complexity here while handling this kind of problems. Next one is handling dynamic configurations. Okay, while working with computed values with dynamic configuration can be error. This often happens in case, for example, I want to create 10 EC2 machines. Then we have one argument or parameter, I can say, called count. If I mention count equal to 10, then it will create 10 EC2 machines for me in the sequential order. Okay, but all these 10 machines will be on unknown values, public IP of it, instance ID, everything will be an unknown. Okay, that is a problem. Okay, while you are creating dynamic resources, okay, 10 EC2 machines or 10 buckets like that. Okay, module outputs are dependent on computer values within submodules. The major impact here is Terraform cannot correctly evaluate the configuration until the upplay phase. Okay, until here, Terraform itself will not know what will be the next. Only after apply, only Terraform knows exact values of each resources. That is the problem. Okay. So, fifth one is drift detection. Drift detection and state management. Okay, while coming to drift detection, computed values can cause challenges in drift detection because their value may change without being explicitly updated by Terraform. For example, okay, auto-generated resources identifiers, consider IP address or token, may not match the state file after external changes. Okay, external changes means if you are creating your infrastructure only with the Terraform, one of your colleague entered into AWS and made some changes, then it will create an issue. Okay, that we can fix with the help of Terraform refresh command, but it may create an issue or until someone identifies it. Okay, Terraform might mark a resources as requiring replacement even if no changes were intended because of that manual changes. Okay, sixth one is interpolation and outputs. Like using computed values in interpolations can lead to undefined behavior when the value is unavailable during the plan phase. Consider I am going to create a security group. Okay, and I'm going to create an EC2 instance. Okay, but I need a security group ID. It will not know until Terraform apply. That is a problem here. Okay, second, seventh one is debugging. Debugging and error diagnosis. Is there any doubt till now? Let me know if you have any doubts. Okay, so this is a new one. So just let me know if you have doubts. Okay? Actually, if you are going to create a new key pair, someone mentioned there's no need to create key pair. If you are going to create a new key pair, then you no need to mention key pair. But if you want to use existing key pair, then you have to provide the detail. Okay, so remember that. Okay. Like while coming to debugging and error diagnosis, the major problem is debugging issues involving computed values can be challenging because error may only surface during the apply phase. Even sometime while you are doing Terraform plan, it will not throw you any error. It will clearly show it will create 2 resources on EC2, 3 resources on a S3 bucket and 1 resources on RDS. Like that, it will show. It will not throw you any error. Right, while you are doing Terraform apply, only it will throw you an error. For example, consider there is some issues with your configuration. Sometimes Terraform plan may skip that, while you are creating Terraform apply, you will have that issues. That is a major problem. Okay, like the log and state files may show placeholders as I computed, making it hard to pinpoint root cause. Okay, and like now we saw the challenges, how to overcome these challenges that we need to know, right? So strategies to address these challenges.
Sir,
What are the challenges? Yes.
so before moving to next, so what 7 challenges you said? So when you are going to do the things in the AWS account using a Terraform, so we are facing these challenges.
What you are trying to say now?
So you said 7 challenges, sir. So when we get these challenges, when we use Terraform in AWS account, right?
Actually, these are all challenges you will face while you are building your infrastructure.
Okay.
Okay, like we will do hands-on, right? I will show you on each phase, like what and all challenges we will face like that. Okay, this is just a theory. Okay, understanding of what to do. While we are anyway, first you need to know theoretically what will happen, right? So first we will learn some things theoretically what and all needed one. After that, while creating infrastructure, we will have hands-on. Okay, with the Terraform. On the time, I will show you this and all the issues. This is how we have to fix like that. Okay, we will go one by one. These are all issues you will face while creating resources. Okay, not not on any other place while creating resources. Okay.
Okay, sure.
Like while coming to strategies to address these challenges is you can use like what you can do is you can use outputs, as I said. You can use outputs for dependencies. If you want to know the public IP, private IP, or instance IDs, anything, you can use dependency. Like you can use output while writing the code, as I said here. Okay. So second one is you can use Terraform data resource. Terraform data source. This is not a resource, this is just a data source. Okay, what is the purpose of it? Use data source to fetch runtime information instead of relying on computed values directly. Okay, so data resources is important. Okay, you can fetch runtime information. Okay, instead of relying on computed values directly. Okay, third one is state dependencies. Well, coming to state dependencies, carefully planned resources dependencies using explicit depends on. Okay, we have one comment we have one parameter called depends on. Using that, you can avoid circular dependencies. Using this, you can avoid circular dependencies. Okay. Fourth one is plan aware output. Plan aware outputs. The thing is, you can minimize reliance on output for values that are only available at runtime, especially in automation workflow. Okay. The thing is, you should be very familiar with creating resources on AWS manually. Then only you can able to relate this with uh, you can able to relate creation of resources automatically. If you are not aware of how to create resources, how to manage resources manually in AWS, then definitely you will not understand anything here. Okay, so then what you can do is just first learn AWS and come to Terraform class. Okay, directly jumping into Terraform class will not help you to understand both cloud as well as code. Okay, IAC. First, you should be familiar with manual configurations. If you are familiar with manual configuration, like automating those configuration is very easy. Okay, external tools. While coming to external tools, use external scripts or tools to retrieve values and pass them into Terraform as input variables, reducing reliance on computed values. Okay, by addressing these challenges, strategically you can manage infrastructure more reliably with the Terraform. Okay, again you need to learn about Terraform, provider versioning, explanation, everything is there. Okay, first these are all things you should know, then only you can able to create resources directly. I can even ask you to install VS Code and directly jump on creating EC2 machine, and I can show this is how you have to create EC2 machine on a Terraform, but it will not help you. Okay, it will not help you at any case. Okay, we will focus both theory as well as practical. Okay, first we will strengthen ourselves in theory. After that, we will implement that practically. After that, we will learn theoretically. After that, we will implement practically. Like that, we will do. Okay. Then only you will get better understanding on each and everything. Still, few things we have to cover theoretically. After that, we will set up. We will install Terraform. We will set up everything, and we will create few resources, and we will check what are the challenges we will face, how to overcome that. Everything we will learn in detail. Okay, so like that only we will go step by step. Okay, first step is learning about challenges and how to overcome it. After that, how to create modules, how to create different resources, how to use data resources, how to use debugging, how to use validate, how to create dynamic blocks, how to tend to resources, everything we will learn. Okay, all these topics we can't use in a single project, right? Depends on need, we will use, right? So while we are learning, we will use by combining possible topics, and we will learn how to implement this, how to implement the infrastructure. So you will get better understanding. Okay, so each phase we will do hands-on session, so you will get more familiar. Okay. Tomorrow also we will discuss something theoretically. After that, I will help you to set up VS Code with the Terraform plugin, and we will write some code and we will play with the code. Okay. So in this course, you will get both theory knowledge as well as practical knowledge. Okay. We will do practical. Okay, let's start. Let me share my screen. Is my screen is visible?
Yes, please. Yes, Kishore.
Yeah, okay. Like last class up to challenges with the current state on computed values. Up to this we have covered. Okay. Still few more theory concepts we have to cover. Okay. So today's class will be theory class. Okay. Tomorrow will be an hands-on. Okay. So what and all we are going to learn up to today's class that we are going to implement on tomorrow's class. Okay, so today also a theory class only, tomorrow only hands on. So from your side, what you have to do is tomorrow while you are joining, you must have a Visual Studio Code and the AWS account. Everyone must have. Okay, tomorrow is a hands-on class. Okay, so one of you going to share your screen and we are going to implement. We are going to create an infrastructure. Okay, I am going to guide you. One of you is going to share, and I'll guide you. We are going to discuss and we are going to create an infrastructure. So don't waste time. Okay, today itself, after this class, if you don't have AWS account, then create one. Okay, no, you should have AWS account and Visual Studio Code. Remember this. Today we are going to start from Terraform provider versioning. Okay, so this is our board. This is the board we are going to use. Okay, even last class we have used this. Okay. Today's date is 22/02/2025. Okay, Terraform provider versioning. Okay. Actually, Terraform providers are plugins, you know, right? So last class itself, we have discussed about resources, providers, and all. Okay. Providers are plugins that let Terraform interact with the API of different infrastructure platforms. This we know, right? To ensure compatibility, scalability, and predictability, Terraform allows to specify the version of the provider you want to use. Okay, this is known as provider versioning. The thing is, if you are not providing any version on your provider.tf file, then Terraform chooses latest version. Okay, for example, if you are working in a team, everyone in your team, like multiple people are working. Okay, everyone in your team, if they are not providing version, then it may choose a different version for each one based on latest version launched by TF. So just give me a minute. Okay. The thing is, it may choose a different version. Okay. For example, while I am working, latest version is 2.4.4. Okay. Like after a few days, Terraform launches 2.4.5, then it will use that, right? It will create unnecessary issues. So while you are creating infrastructure, we all, those who are going to involve in the project, those who are going to work together, they have to use the same version. So providing version in Terraform.tf file is a better way. For example, in provider.tf file, if I mention 2.4, if another person also going to work on the code means, since 2.4 is a like a provider version, then obviously he will also use that only. So we can avoid unnecessary issues. Okay, why provider versions are important? Okay. While coming to, it's a major purpose. First one is backward compatibility. Okay, first one is backward compatibility. What is backward compatibility? Like how it is important. The thing is, providers may introduce breaking changes in new versions. Okay, so specifying a version ensures your code won't unintentionally break when provider is updated, as we discussed. Okay, that's why we have specifying version. Second one is stability. Like using a specific version ensures consistent behavior across the environments. Okay, if you are using, if you are creating infra and staging, and if it is working as expected, then you can use the same code for production also. Okay, if you are using proper version without making any changes, just you can create one more new workspace and you can use the same code. Okay, we can save bunch of time. Okay, third one is team collaboration. What and all I have discussed it, that one, that is the major advantages here. By coming to team collaboration, when multiple developers work on the same project, specifying a version avoid mismatches in the provider behavior. Okay, so only we have to specify. Like last is, we can avoid major surprises. Like Terraform automatically fetches the latest provider version if no version is specified, which might lead to unintended upgrades. Okay, these are all the major purpose we have. Because of this only we have to provide the version. Then you can have a doubt like how provider versioning works. You may have this doubt, right? Let me explain. Provider versions are specified in the required providers block. Okay, while you are writing provider.tf file, we will have one block called required. By tomorrow you will see this required underscore providers block. It should be smaller one here. Okay, block. Okay, within Terraform configuration, within TF configuration. Okay, this allows this block allows you to define like name of the provider and version of version constraints. Okay, for example, here itself I will write every time, even while we are discussing theoretically, I will write all the syntax and all the code. Okay, then only while we are doing practically you can able to connect it easily. Okay, now I want to write the provider.tf code, then I can write with the version. Consider this is my provider.tf file. As well as this are not must. Okay, while creating infrastructure, we will use some of the concepts we may not need every time. So only if I am writing that code here and if I explain while we are doing theory itself, in practical if that is not needed, some concept is not needed, And since it is not needed, since we haven't written also, while in your case, if it is needed, you may remember, okay, right, while we are writing the code in a theory sections, then you can understand, oh, for this purpose we have to write like that. You can able to connect. That is the reason. Okay. Now I am going to write here provider.tf file. Okay. Now, first you have to start with Terraform block. Terraform. Everything it should be a small. Okay. Like the thing is, it is auto correcting, so you can avoid that. Okay. All classes I'm saying, just remember Terraform. Here when I said right, one block required providers block. That is that we have to write here. Required providers. Under Terraform, you have to create one more required providers. Yeah, actually, if you are storing this file under .tf, it itself automatically will correct syntax. Okay, cursor under it itself will automatically provide. Okay, in Visual Studio Code. Here, this is just a notepad file. I am just adjusting it. Here you have to mention source from where it can. Everything is small. Okay, here after I won't correct if it is in capital also, because everything is small as I said here. So from where it should fetch plugins, where it should get plugins from HashiCorp, because Terraform was developed by HashiCorp, right? So HashiCorp AWS, okay, and version. This is the reason we are learning this. Okay, version. You must provide version like a parameter while you are writing provider.tf file. Here you can provide any versions like this. For example, now I am going to provide a version constraint as title symbol. I'll explain that. Title greater than 4.0. Okay, I'm just providing like this. I'll explain, okay, why I am doing this. And I am going to close the curly braces. Okay, here this specifies the namespace and provider name, and this specifies the version constraint. While coming to version constraint, we have so many things to learn. Let me write those symbols and I'll explain. Okay, like here you need to learn about operator. Okay, this is one of the operator. Okay, so for example, what is the purpose of this? This is the symbol, right? What is the purpose of this operator? The thing is, for example, now I am using this as a okay, my operator example. I am how I am using this. Consider I am using this with 4.0, right? So what it indicates? What it indicates? What it will do is it will use versions compatible with greater than or equal to 4.0, but not greater than 4.3. Okay, so it will choose the version between 4.0 to 4.2. like up to 4.3, but not greater than 4.3. So it can use 4.0, 4.1, okay, and 4.1, 4.0, and 4.1. Okay, not even 4.3. Sorry, 4.1. One version only it can able to use. Okay, so the thing is, if I'm using 4.0, then it must be 4.0 or greater than or equal to 4.0 or greater than 4.1. It should not be like more than that. Okay, for example, if I am using here 3.2.0, okay, then what what will be the range? Can someone tell? Because it is difficult to understand initially, so I am asking. Can someone tell the range if I am using 3.2.0? What will be the range up to what it can use? Can someone tell? You need to tell greater than or equal to value and greater than value.
Is it greater than 3.2.0 and
Yeah,
less
correct.
than one version 3.2.1? Is it?
No. You have to focus on this bit value.
Okay, so 3.3.
Yes, 3.3.0. Okay,
Okay.
it will choose in between this. Correct, absolutely correct. Okay, this is how it works. Okay, if I am using equal to symbol, consider okay, 3. I am just using equal to 3.2.1. Okay, then it will use the exact version. It will use exact version. Okay, 3.2.1. Okay, now if I am using greater than symbol, okay, these are all the operators. Okay, so one by one we are discussing. Okay, if I am using greater than 3.2.0, okay, I'm just using greater than 3.2.0. Can someone tell how it will fetch? How it will use the version? If I provide greater than 3.2.0, it is easy only, right? Even if it is wrong, no issues. Okay, since we are learning, it's not an issue.
Is it like anything more than 3.2.0 but not 3.2.0?
Yes, correct. It will use version greater than 3.2.0. Correct. Okay, it will not use less than 3.2.0. Okay. Okay, now one more thing. Greater than equal to 3.2.0. How it will fetch version?
So is it including 3.2.0 and greater than that as well?
Yes, it will use versions greater than or equal to 3.2.0. Okay, now one more operator. Now if I mention like this, how it will fetch the version, how Terraform provider will fetch the version and Samantha. Even if this
Not
one
equal to.
means like how it will work if I provide this as my version.
So
Like
it should not be
except
equal to 3 point.
I can't understand one by one.
is there anything not but to 3.2.0? Maybe it might be lesser or it might be greater. I'm not sure. But apart from 3.2.0, whatever versions available, I think it can use.
Yeah, at last you said right, that is correct. It will use any version except 3.2.0. Okay. Okay, good. Okay, like now one more thing. Just guess this also. 3.1.0 rather than 4.0. How it works? This is the last operator. Just tell me. Actually, you can here we are using greater than or equal to, right? You can use less than or equal to also pass. Okay. Now, can someone explain this?
Is it
It
like
should be
from 3.2 till 3.9?
Yeah,
Oh,
correct.
no. 3.1 is also included now, sir. So 3.1 to 3.9.
No, like exactly like how it will fetch. Anything it may fetch, right? Like from 3.1.0 to 3.9.0.
9.0. Yeah.
Can fetch anything. Then how it will work? Any guess? Yeah, range is correct. Okay. Like how it will ensure the compatibility. Mostly we will not provide like this, okay, because there is a huge difference between one and another. Okay, mostly it will like we will use these parameters but with lesser versions. Okay, like for example here we have specific range. It will commonly use it to ensure compatibility with breaking changes. Okay, it will check, okay, from 3.0 to 1.0 to 3.1 or 9.0. Okay, which is compatible and which is standard, it will choose that. Okay, but mostly we will not use like this. Mostly we will use this. Okay, or we will use this, which is better. Okay, remaining things are not we have, but we will not use much. Okay, but it will ensure the compatibility. Okay, while choosing. Okay, now we know like where to specify. This is the provider version. Okay, here we have to update with this operator and specific version that we need. Okay, this is the provider.tf example file. Okay, now we will learn how Terraform TF handles provider versioning. Right? We need to know this also. First, what we will do to create infrastructure, we will use Terraform init command. That is for initialization. What it will do, it will initialize the working directory and it will set up the backend. Okay, it will install the provider plugins and it will set up the backend. Okay, for remaining commands to execute to create an infrastructure. Okay, initialization. Initialization, that is Terraform init. Okay, like what it will do is Terraform downloads the specified version of the provider from the Terraform registry or another source. Okay, after that, if no version is provided, it downloads the latest available version. Okay, because Terraform init is the responsible for to set up the backend system. So this is the one who is going to install. This is the command. Once we enter this command, it will trigger the provider. Okay, provider plugin to download the specified version as we specified. Okay, so how it will do? It will Terraform init will interact with Terraform registry and it will fetch the required version and it will install the required version. Okay, it will set up the backend system for that working directory. Okay, one more file you will find tomorrow while we are doing it. Okay, second one is version locking. Okay, this is not a command. While you are executing this, automatically it will create this file. Okay? The file name will be .terraform.log.hcl because Terraform uses HCL language. We already know, right? So Terraform maintains a dependency log file called .terraform.log.hcl to track the exact version of each provider used. The log ensures consistency by locking provider versions across different environments. For example, you are using 3.2.0. Okay, what Terraform log.hcl will do? It will create a dependency log with the exact version of the provider and it will lock it. So until you complete the infrastructure, since you provided Terraform like a version as a 3.2, it will use 3.2 only. Okay, every time while you are executing command, Terraform will go here and it will check the version and it will use. Like that, it will work. Okay, if you are going to change version, then you have to change your. For example, if you are using 3.5, then you have to mention 3.5 here. Again, you have to execute init command. Then only it will update Terraform log.hcl. If you are instead of using Terraform init, if you are going Terraform plan directly, it will throw you an error. Okay. As well as you should, if you are using, if you are going to upgrade your provider with the 3.2.0 to 3.5.0, just using Terraform init will not work. You have to use Terraform init upgrade command to upgrading providers. You have to use Terraform init upgrade command. You have to use. So only it will update this file with the latest version. Okay. For example, Second time while you are doing this, you are just removing it. Okay, instead of updating to 3.5, if you are just removing it, means while you are doing Terraform init upgrade command, it will use the latest version. Okay, so using latest version is not recommended. So just specify some versions, it will be good. Okay. Now, best practice. Okay, these three things. This is how Terraform handles provider version. While coming to best practice for provider versioning. While coming to best practice, you must specify a version. Okay, I have already explained to prevent unintended updates by explicitly specifying a provider version of constraints. Okay. Second one is version pinning for production. Version pinning for production. Like for production environments, pin the provider to a specific version. Okay, instead of using this kind of command, like this kind of operators, go with exact operator. That means equal to some version to ensure no unexpected updates occur. Okay, while going to production, go with exact version. Okay, so the thing is, while you are creating stage environment itself, go with the exact version. Mostly we will go with the exact version. These are all possibilities you can use. Okay, but 99% we will use this one. We will go with exact version to avoid unnecessary issues. So we can use the same code for production also. Okay, so and you have to regularly update the constants. Update constants. Okay. The thing is, you have to periodically test and update your constants to take advantage of new feature or fixes. Okay. If you are going with a new version, then you can update new version and you can use a Terraform upgrade command, init upgrade command. Okay. And one more important thing, while you are pushing your code to source code management, push dot terraform dot log dot HCL also. Okay, always commit the log file to version control to maintain consistency across environments. Okay. Next one is test provider updates. Before updating provider version.
Hello.
Yes.
Can you repeat the previous point, please, Kishore? The commit thing.
See, the thing is, while we are writing code, since we are creating our entire infrastructure in code, right? So
yeah,
we can use version control system like GitHub, GitLab, Gitbucket and all to store our code. So anyone in your team can access your code at any time without anyone dependencies, right? So initially I am the one creating infrastructure. Okay, you are my teammate. Okay, so I need to create 2 services. After that, you have to create 2 services. So instead of sharing locally, if I push my code into GitHub, you can easily clone that and you can write on your functionality, right? Once I am done. So while I am pushing, I have to push this file also. Because if I push this, so while you are doing Terraform in it, it will it will read the provider file as well as it will confirm with terraform.log.html. So yeah, this project is using 2.3.5. So we can go with 2.3.5 like that. It will decide, and while you are creating services also, it will use the same version. So we will not face any issues. Okay. So while like you have done your job again, I have to work means while you are pushing, you also can include the this log.hcl. So we can maintain consistency, okay, across this environments. Okay, so we can ensure that we are going on the same version. Okay, commit means like you can use just a source code management to like GitHub to commit your changes, commit and push
Okay.
your change. Understood?
Yes, Kishore. Got it. Thanks.
Okay. So the provider versioning in Terraform ensures stability and compatibility in managing infrastructure by explicitly defining provider version or constraints. You can avoid breaking changes. It will enhance the collaboration and maintain consistent deployments across this environment. Always adopt best practices like committing the log file and regularly testing upgrades to keep your infrastructure up to date and secure. Okay, this is the best practice. Okay, now we have completed this. Now we are going to learn about read, generate, modify configurations. Okay, so up to today, what and all we are going to discuss that we are going to do tomorrow practically. Okay, our next topic is understanding attributes and output values in Terraform. Okay, is there any doubt till now? Because most of you are new to Terraform, just let me know if you have any doubts. I'm going slowly and I'm explaining everything in depth. Okay, most of the people while coming to Terraform classes, like taking Terraform classes, what they will do is they will just ask you to install VS Code. They will ask you to they will just provide some code and they will explain it, and they will ask you to create infrastructure, and they will say it is completed. They will just to make to while coming to version providing, they just explain this with the two examples. Okay, and they will show you this is how it will work. Okay, but definitely it will not help you. Terraform is an infrastructure too. Okay, while you are building infrastructure, you need to know end to end what it will happen in next, or how each parameter, each component is working. Okay, you can get bored in a chat GPT or DeepSeek itself, right? So that is not an issue. That is not the writing code is not the big deal. Okay, understanding concept is needed one. You can just copy paste the code from ChatGPT and you can create an infrastructure. Tomorrow, if there is some issue or some data is leaked, okay, due to not practicing, due to since you people not practice the best practices. The thing is, if you are pushing your state file, then everything is gone. Your public IP tokens, passwords, everything will be explored. If you are pushing your state file on GitHub, because it will store all the tokens, passwords, sensitive data, everything, your IP addresses, your key, PEM key, everything it will be exposed to the internet. Okay, so each and every component you have to learn. Okay, now you know, right, what is the purpose of versioning, what is the purpose of provider. So while you are choosing version itself, you will know that the importance of provider. Okay, so that's why I'm taking time and explaining it, as well as 1 month is more than sufficient to learn Terraform with this kind of detailed information. Okay, that's why we are going like this. Okay, so utilize it. Okay, so because in real time creating infrastructure is crucial. If you made a single mistake, it will create a big problem, as well as it involves money also. Since you are creating infrastructure on AWS, by mistake, if you are creating 10 or 15 machines while using count parameter, then your bill may increase. So each and every parameter, each and every attribute is very important here. Okay, so only I am providing detailed guide on each topic that we have in our syllabus. So make use of it. Even at the end of this class, you can become an infrastructure engineer. Okay, most of the companies nowadays they need an infrastructure engineer. It will come under DevOps also. Okay, they will name it as DevOps engineer, and if you're like mostly they will specifically they will focus on infrastructure. If you know only Terraform, forget about remaining tools, Jenkins or this kind of tools. If you know only Terraform, you will get a job. Okay, this option will be applicable for Kubernetes also. If you know only Kubernetes also, you can easily get a job. Anyway, Kubernetes basics is Docker, so you will already you should learn Docker and Kubernetes. Okay? So for this kind of tools, we have an added advantage like this. Okay, so learn Terraform like with the standard, it will help you. Okay. Now, like our next topic is understanding attributes and outputs in Terraform. Attributes. Okay, while coming to attributes, like attributes represent the properties of resource defined in Terraform. Okay, simply if I want to say what is attributes, this is the definition. Attributes represent the properties of resources defined in TF. I mean Terraform. Okay. Like for example, in an EC2 instance as attributes like public IP, public underscore IP, private DNS or instance ID. For example, after creation, you need instance ID of that machine names. You can use attribute called instance underscore ID. Okay, so while writing output file. So it will, after creating resources, it will show you the instance ID of the machine. For example, after you are creating an EC2 machine, after creation, you need to know the public IP of it. Means you can use attribute called public underscore IP. Okay, and for example, you need private DNS details. Then you can use private underscore DNS. Like that, you can use this and all. We will call it as attributes. Okay. Static attributes. While coming to static attributes, there are two types of attributes out there. One is static attributes. Static attributes. While coming to static attributes, we have to explicitly define in the resources block. Second one is computer attributes. Okay. It is generated or populated by Terraform. It is generated or populated by TF. Okay, example public IP. This is and all instance ID, public IP, private DNS and all will come under static computer attributes. Okay, these three will come under computer attributes because these are all populated by Terraform. populated by Terraform. Okay, like how you can use this? You have to use this with the help of output block. Okay, now I'm going to create an EC2 machine using this attribute. Okay, now I am naming this file as ec2.tf. Okay, now what I am going to do is I'm going to create a resource and I'm going to use the computer attributes to get some data. To get some data means, example, I need an instance ID. After EC2 instance creation in Terraform, I need the instance ID. I need to, instead of log in into my AWS account and to view my instance ID, I need to view that in my terminal itself. Okay, that is my goal. Okay, that how I can achieve it by writing code. Okay, now I am going to create an EC2 instance. Resource we already learned resources and provider block, right? Using resources block only we can able to create the resources. Okay, resource AWS underscore instance is the instance type. Okay, like not instance type, this we can call so resources type. Okay, AWS instance is the resources type. Here you have to mention the local resources. That is, I'm just mentioning it as an example. Okay. Okay. AMI. If we want to create an EC2 instance, then we need AMI. I'm just providing AMI. Everything will be in small letters. Okay. Ignore capital. Okay. I'm just providing this is my AMI. And instance type I need to provide, right? So I'm just providing instance type. ST2 micro, which is free tile, which will be under free tile. You don't need to pay for this. Okay, I'm just closing my resources block. What it will do, this command is like this 3 lines is enough to create an EC2 machines. Okay, it itself will create a key pair value and it will create instance for it. But after creation, I need to see the output in the terminal itself. Okay, I can create the like I need to see the instance ID in my terminal itself. Then only output block will come into the picture. Output instance underscore ID. I'm just providing value. Inside that value, you have syntax is resources type dot local resources dot ID. Okay, this is the syntax. How I am going to write that syntax? My resources type is AWS instance. If you are using resources type as AWS instance, AWS underscore instance, it will create an EC2 machine. If you are using AWS underscore RDS, then it will create RDS. Okay. If you are using S3, then it will create an S3. Okay. Using resources type only, it will create resources. Okay. Terraform uses resources type to create a resources. Here I am using AWS underscore instance. So what it will do? It will create an EC2 machine. Okay. So first I need to specify my resources type and my local resources, what name I am giving here. And since I need an ID, I just mention ID is enough. So it will create EC2 machine. After creating EC2 machine, it will provide my ID, instance ID. In computed values, we learned, right? It will not, you can't able to see like a public IP details and instance ID details and all on plan space or apply base. We can only see after resources is creation. When it will execute after resources is creation. After resources creation, it will show that. Okay. Here, attribute ID is used to output the EC2 instance ID after creation. Okay. What is the purpose of output values? Okay, use it to display information after Terraform applies a configuration. Okay, it helps to pass data to other modules also if it is required. Okay, for example, the same EC2 machine, I need to get public IP also. Then same only. Okay, what you have to do is here we can mention public IP, public underscore IP. Okay, this is also one of the computed value, computed attribute. Public IP. Here you can use public IP. Okay, and resources type, local resources, and like a computed attribute, right? So here same is AWS underscore instance example. Here you have to mention public underscore IP. Okay. Additionally, for best practice, you can describe here what purpose you need. Okay. So here you can write description like I need public IP of the EC2 machine like that. You can use description block. So yeah. Okay. If you are not using also no. Okay. Second one is referencing class account resource attributes. Okay. When managing resources across multiple accounts, you can reference attributes from one account in another by using remote state data. Okay, like again I'll repeat it. When managing resources across multiple accounts, okay, if you are using multiple accounts and you want to you can use reference attributes from one account in another. Okay, one account in another by using remote state data. What it will do is it will access the state file of other account. So this and all like while doing hands-on, this and all not required. Okay, because we will not use this case for every time. Okay, so that is the reason I am writing everything with the code. Some of them we will use, there will be a need. Some of them we will not use, there won't be a need. So since you have to get the knowledge of entire syllabus, only I am writing here. Okay, now I am going to write the Terraform remote state. Okay, just to access, just for reference attributes from one account in another. Okay, now I am going to do it. Now I will write and I'll show you. Here we have to use data block, not resources. Here we have to use data. What is the purpose of data? Last class we have discussed it. Can anyone tell? Data block. Just tell what you know, even if these are no issues. Even if you don't know, just let me know, don't know, so I can carry forward with the continuation. Okay, we will use data to fetch the data from external resources and use that in Terraform configuration file. Okay, to fetch the data from external resources and use that in the Terraform configuration. That's for that purpose only we will use data. Here we need a state file of other account, right? So what we are going to do here, we need some file from other account. So we need to fetch that and we have to use that in our configuration, right? So only we are using data block here. Okay. In data block, everything will be in small letters. Okay. So data will be also small. So Terraform, this is resources type. Terraform remote prod, like better I use state here. State, actually the state is the correct one. Here you can write any name, right? This is local resources. I'm just giving it as prod. Backend. I'm just using S3 for backend to store the data. Everything will be in small letters. Remember that. Config. I'm just providing bucket details. Bucket. In which bucket you are going to store that file. Bucket. I'm just providing bucket name as prod tf state. This is my bucket name and my key. What I'm specifying here key is that state file. Okay, because I need that state file of other account, right? So I have that state file under EC2 underscore Terraform. Okay, under EC2 folder, I have that state file dot tf state. State file always ends with dot tf state. Okay, under region, and I'm specifying region as AP South 1, that is Mumbai region. Okay, I'm just closing this. Okay, and in resources also we can write, but this is enough. Even you can call while, for example, you are going to create a security group and you want to add that also, you can add that in a VPC ID, but this is enough. Okay, this is how we will referencing cross account resources attributes, but mostly we will not use. We will not use this concept. It is not needed for us because it will create unnecessary confusions. Okay, for example, if we are creating an infrastructure and we are creating resources in the infrastructure, that state file is different. If you are creating another infrastructure with the different components, that state file is different. Mostly there won't be need for us to use state file of that infrastructure. There won't be need, but since this is a tool, they have created this tool for all purpose, all kind of ways and purpose. Okay, so this is one of the way, but we will not use that, and there won't be need for us. Okay. Third is important one. I think Terraform variables. Let's say, yeah, Terraform variables. Okay, while coming to variables, okay, which is important topic, and we will use this frequently in Terraform. Okay, what variable will do? Variables allow you to parameterize configurations, enabling reuse and flexibility. Okay, declared using, it will be declared using variable block. Okay, we will use variable block and we will declare that. Okay, what and all we can have. Can have default values, descriptions, type constraints. Okay, I will write an example variable. Like for example, I am going to create a variable.tf. Then how I can write variable here in description. We have to provide description for that variable. I'm just giving as AWS region. I'm going to create this variable for AWS region. Okay, and in type I am giving a string. Okay, here type constraints we have used, description you have used. How I can use default values? Default. If I use this variable, by default it will use this region. Okay, while I'm creating EC2 like EC2 instance, if I want to specifically deploy this on Mumbai region episode 1, then I can call this variable called region, where dot region. That is enough. It will use Mumbai region and it will deploy it. So we can reduce the number of lines, as well as we can use the code. Okay, we can reuse the code. Okay, this is how we have to write variables. Okay, is there any doubt till now? Since everyone have access to this board, I'll give 5 minutes time. Okay, don't left the meeting. Okay, just have a look at what and all we have discussed till now. Okay, now time is 3:17, right? 3:25 we will start again, because if I keep on explaining, you may confuse. I'll just give 5 minutes time, just revise it. After that we can go with the fourth approach. Okay, fourth one. Okay, let's start. Fourth one is approaches for variable assignment. Like Terraform supports several methods to assign values to the variable. Okay, one is CLI input. Second one is environmental variables. Third is you can use Terraform TFVARs. Terraform dot TFVARs. Okay. Fourth one is default values. Fifth one is variable overrides. Overrides. Okay. The thing is, while coming to CLI output, example is, for example, instead of writing variables in the variable file, what you can do is, while running Terraform apply, you can inject the variable. How you can do that is, but this is not recommended. Okay, mostly we will use variable file only to declare the variables, but these are all the possible ways. Okay, we can use export like environmental variables, but remaining things we will not use. We will go with variable method or we will go with environmental variable method. Okay, remaining things mostly we will not use. Okay, we'll come to CLI output. While you are applying, you can inject the variable. How you can inject this? For example, Terraform apply. Okay, this is the command to apply, right? So additionally, I can inject the variable with the help of var command. -var equal to, in double quotes, you have to mention the region, okay, and you have to specify your region. Okay, like this is how we have to use CLI input. Okay, while coming to environmental variable also we will use, but the best practice is creating variable file and writing the code. Okay, how you can use environmental variable is with the help of export. Okay, you can use export, and you have to use the export key and value. Okay, now I am going to specify key as tf underscore where it indicates Terraform variable, and I am going to use region, right? Region equal to AP South 1. This one it's difficult to remember as well as difficult to check every time. That's why we are writing in the code. Otherwise, you can use the best practices. You can use variable.tf or you can use terraform.tf fast. But some people they will use environmental variable also, but this is also not recommended. Okay, which will not provide more comfortable. You can use Terraform var files, okay, and you can write code like this, like how we are writing variable code like that. You can write the code here. For example, region, what you can do is you can write this file and you can mention region equal to episode 1. Like this, simply you can. While coming to default values, if no other value is provided, then default is used. Here, here while writing variable, I am specifying default, right? Why? While if I can use where dot region to call this region, as well as if I am not specifying any region while writing code, by default it will use the default region that I have specified. Okay. Well, coming to variable overrides, values from the CLI or environment take precedence over default. You specified default as AP South 1, but while you executed this command with a different region, which has more power. Okay, it will use, for example, here if you are using a US East 1, then it will use US East 1 only to create your infrastructure. It will not use AP South 1 because it has more power. Because while you are running, you are giving it, right? So it has more power. Okay, but you can use one. Okay, you no need to use multiple things. Using one is enough. Okay, just go with variables.tf file, or go with tf class. Okay. Next concept is data types for variables. Actually, there are two types of variables or types are there. Okay, one is primitive types. Second one is complex types. Okay, while coming to primitive types, here we will use string. Like here we have used string, right? Like that. Okay, string, or we will use number, or we will use bool. While coming to complex types, we will use data types, okay, that we will use in programming, like a list or map or object, or we will use tuple or any other, okay, etc. We can use. Okay, this is why coming to data types for variables. These are all the types we will use. Sixth one is fetching data from maps and list in the variables. Okay, how to extract values from list and map that we are in complex data types? That one we are going to discuss. For example, how you can write for list is from list. First, we will learn about list. Okay. First, I am writing variable. Variable. Consider that I am writing this for security group. Okay, variable. I'm just giving a ports. Okay. Actually, in my security group, by default, I need this ports and all be enabled. Okay. If it is not needed, then I'll itself specify the port, like port specific port. Okay. By default, it should enable. If I am not specifying any ports, by default, it should enable SSH port, that is 22, and HTTP port, that is 80, and HTTPS, that is 443. I need this ports should be enabled. But sometimes I can call, like for example, while writing code, I need only 22 port, then I can call it, right, easily. While I am writing security group, okay, resource. I'm going to create a rule, right? So I'm just going to write resources as AWS security underscore group underscore rule. And I'm going to give name as example here. From port, I need only 22. Then what I can do? I can easily get from that. Okay, I can use where dot ports. In list, I can call 0. list like arrays always start from 0, so it will fetch 22. For example, if I need 443, then I use 2. Then what it will do, it will fetch, it will use the 443 port. Like that I can based on my need basis, I can use the port, okay, while creating the resources group, like a security group. Okay, this is one of the use cases. While coming to maps, now we will come to map from maps. Okay, for example, I need to use, I'm going to deploy my application on multiple region. So in each region, I need to use different app. Then to create a EC2 machine. Okay, then I can use map. Map is the best for this. Okay, how I can write this variable and I can mention AMI map. Here in default, I can give regions with the AMI. For example, new US West 1, I need this M for US East 1, 1 equal 1, it will. I can provide different AMI. Okay. So what I am trying to do for US East 1, I need to use this AMI to create servers. For US East 1, West 1, I have to use this AMI to create servers. For East 1, I need to use this AMI to create servers. Then how I can call this? You can call easily with the help of output. Output AMI value var dot, and you can call this variable AMI underscore map. Okay, and I can call the required one in this map inside the list. This is how we have to use the map, a map variable. Okay. One more topic we will discuss and wind up. Tomorrow, for first 30 minutes, we will discuss theory concepts. After that, we will deep dive into practical sessions. Okay. Now, another one is count and count index. The purpose is, if you want to create 10 EC2 machines, okay, then you can use count and you can create the 10 EC2 machines. In count, if you are mentioning as 10, then it will create 10 EC2 instance for us. Okay, while giving tag, for example, there is a need for you to give tag. Okay, then you can use count index. Okay, it will start from 0. So if you are going to create 3 EC2 machines, then it will, for example, if you want to name that EC2 machines as instance 0, instance 1, instance 2, like that, you have to create tag names. Then you can use count index. Okay, let me write and show it to you. Okay, count is a meta argument. Okay, it will allow you to create multiple instances of resources. Okay, remember that count.index provides a zero-based index for each instance. Okay, so I am going to create a list. Better I'll copy above in a way I have written. Yeah. Okay, this is my instance, but additionally I need a tag. Okay, tags. Consider I am going to create 5 instances. Okay, then I can mention count here as 5. Count equal to 5. In tag, I need to name. I need a tag for each instance. Then here I can use name equal to instance ifm dot index. And I'm closing this. What it will do is every time I creating instance, it will create tag also. Instance 0, instance 1, instance 2, instance 3, instance 4. Like that, it will create the tag also. So it will create 5 instance with the tag with a different name. Okay, so you can easily differentiate the instance. So it will create 5 instance from tag instance 0 to instance 4. So totally 5 instance it will create with this name, with this tag name. Okay, this is how it works. Okay, tomorrow first 30 minutes we will discuss some theory concepts. After that we will set up Visual Studio Code and we will set up Terraform environment and we will work on creating the infrastructure. So you will get good hands on. Okay. This is enough for today. We will discuss few topics for first half an hour. After that, we will have hands-on. Okay. So let's start. Others, mute your mic. Just give me a minute. Let me share my screen. And I'll open syllabus also. Okay, let me share my screen. Is my screen is visible?
Yes, Kishore.
Yes or not?
Yes.
Yes.
Okay. Okay, like last class, up to fetching data from maps and list in variable we saw. Now we will look into count and count index. Today we will discuss up to Terraform format. Okay, and validating. Okay, up to validating Terraform configuration files. We will see in theory part. After that, we will do hands-on. We will set up and we will do hands-on. Okay, so let's start. Okay, like our next top, like our topic, now is count and count index. Okay. Like, is there any doubt that we have done in our last class? Just let me know if you have any doubts. So I can clarify your doubts before starting new class. If there is no doubt, just let me know so we can move further. Can we start then? Since no one has responded. Okay. Like now we are going to discuss about count and count index. Okay, let me type count and actually A is not working in my keyboard. That's why it's happening. Okay, count and count index. Okay, actually, why we need count and count indexes? For example, consider if there is a need for you to create 10 EC2 machines. Okay, but it is difficult to write 10 times that resources definition, right? For example, actually, we already covered count and count index also. See, next topic only we have to follow. Anyway, okay, let me explain count and count index. For example, if I want to create 5 EC2 machines, like wait, let me show you. Yeah, okay. Here, for example, if I didn't mention this count, what it will do? It will create only one EC2 machine. But if I want 10 EC2 machines, instead of writing this resources definition for 10 times, if we have any attribute where we can specify our count will be better, right? So Terraform has count and count index. So in count, for example, if I provide a 5, then it will create 5 EC2 machines. Okay. Count indexes, it will always starts with 0. So it will create instance from instance names 0 to 4. So overall 5, 0, 1, 2, 3. Okay, 4. Okay, totally it will create 5 EC2 instance. Okay, so you can specify count if you want to increase the number of instance creation. Okay, if you want to create 10 instance, then you can mention 10. If you create if you mention 1000, it will create 1000 instance. Okay, depends on the value it will create it. Okay. Okay, next topic is conditional expressions. Okay. Conditional, again, A is not working. Just try to understand. Okay. Expressions. Okay. Yeah, conditional expressions. Okay. What is the purpose of conditional expressions? Actually, conditional logic. Okay. To decide resources, attributes, or behavior. For example, in real time, we will have multiple environments like a stage, dev, production, pre-production. Like that, we will have a number of things, right? So, using conditional statements, for example, if it is stage, then use T2 micro. If it is prod, then use three large, because in prod real time traffic we will get, right. Like that also we can configure. How we can do that is like first I'll write variable. Actually, it's not working. Unfortunately, it's not working. A variable env. default equally everything is, should be small letters only. Okay, it is auto correcting, so I'm just going further as I said in last class. Okay, so consider actually now I am giving my default environment as production, right? But I can check this value while creating instance. How I can do for in that only I am going to use conditional expressions. Okay. Resource, like since we are going to create AWS instance, so resources type is AWS instance, and in example we have to give instance type, right? Instance type equal to, here I can use that variable that I have declared here, that is var dot env equal to prod. If it is equal to prod, if it is equal to prod, I need to assign T3 large. Otherwise, I need to assign T2 micro for except to prod. If I'm using any other environment, then I have to use T2 micro only. Like that, I am configuring. So you can use conditions like this. You know what this code, this code will work is, if it is production, then it will use T3 large. If it is stage, then stage or any other environment apart from production, it will use T2 micro. Okay, this is how you can inject the conditional statements, conditional expressions. Next one is local values. Local values. I'll just check whether I have virtual keeper. Okay. Local values. In local values, like the purpose of local values is, it will locals just like what it will do is, it will simply config by defining reusable expressions. Okay, like it simply configs by defining reusable expressions. Okay, if you use local values, so how you can inject like that, you can ask, right? So actually it is same like variables only. Like instead of using variable, we can use locals. Okay, there is not much difference. Just I'll show you the example. Locals, and region, I'm just using AP South one, that is Mumbai region. A is not working. Okay, so while you are reviewing this, just use A some like, okay, if you are getting any doubts in the value T2 dot micro. Okay, now I'm just declaring my locals as T2 micro. What you can do is just you can inject this instead of mentioning T2 micro on instance type, you can just mention local dot instance type. Okay, mostly we will not use locals. Okay, remember that we will not use this. We will use variables only. There is no use of using locals. Okay, since we have this in our syllabus as well as in Terraform concept, I'm just explaining you this. And while coming to instance type, I can call local and I can tell local and I can use instance. For that, I can directly use my instance value itself, right? So only we are not using locals. Okay. So next topic is Terraform functions. Terraform functions also we will not use. Okay. I'll just discuss Terraform functions. Okay. Ninth one is Terraform functions. Like the purpose of Terraform function is which provides built-in functions for string manipulation and as well as math, as well as type conversation, etc. Okay, the thing is, example is, for example, how you can use string manipulation is, for example, I need a allow in small letters. It's like a programming language. Okay, in Python program, we have lower, higher, upper, like that is we have, right, like that earlier also. For example, I am giving input as lower allow. Okay. Then Terraform, what it will do is it will provide output as hello in small letters. If you need in capital, then you have to use up. Okay, if you're providing length here, then it will count to each element and it will send you the output. Okay, this is the Terraform functions. Okay, 11th one is data source. Data source only, right? Local functions, local values, Terraform functions, data source. Yeah, correct. Data source. Unable to copy paste. Okay. Data functions. That is 11th one. Okay, while coming to data functions, what it will do is data source fetch data from external systems to use in Terraform configuration. That is the purpose of data function. Okay, what it will do, it will just use to fetch data from external systems to use in TF functions, in TF manufacture, TF manifest file. Okay, the thing is, if I want to explain with an example, for example, consider every time while we are creating instance, we will copy the AMI from AWS account and we will use that in our Terraform configuration. But you are not willing to copy paste. You want to fetch it automatically. Then you can use data source. What it will do, you have to provide details like who is the owner of that image. Amazon is the owner, and I need a Amazon Linux too. Then you have to mention that name, and you need to mention version also. Most recent equal to true. If you provide like that, then it will fetch the latest version for you. Okay, this is how this works. Okay. Next is debugging. Debugging in Terraform. Okay, like actually, this is one of the useful feature in Terraform. Okay, you can use TF underscore log. Okay, as an env variable. Okay, so you will, for example, if there is any issue, it will provide more information on that issue, so you can easily able to fix. So if you are new to Terraform, then you can use this command export small letter. Okay, tf -log equal to true, not true, debug. If you provide like this, it will provide a more detailed logs for you. So since if you are new to Terraform, you can easily using this, you can able to fix without anyone dependencies. Okay, even in my initial days while I am learning Terraform, what I have done is I just use this command, so I get detailed logs. So using that I got familiar. Now I can able to work without this tf log underscore debug. Actually, Terraform plays a major role in interviews. Okay, so provide more like spend more time on Terraform. Even now I am planning to switch. Okay, so most of the companies spending much time on Terraform only. Even like I am getting I'm getting shortlisted because of Terraform only. Since I am very good in Terraform, I can able to explain any concept. They are simply shortlisting me. They are not even checking remaining things. So Terraform plays a major role while coming to interview. Like how I got familiar is, if you are normally working for a company, it is difficult to remember all the concepts and the syntax. But the thing is, I am here working as a trainer, right? So every month I will do Terraform batches. So I know like each topics, right? So I'm just explaining like how I am explaining this to you people. So they're simply not even asking more than 10 questions. Okay, they're like they itself will tell if you are able to answer well. They tell you are good in Terraform, so we can move next, like that. If it is specifically infrastructure role, then they will shortlist you on the call itself. So these are all the advantages. Okay, so most of the companies spending more time on Terraform on interview. Even I am applying for DevOps role only. I am not applying for infrastructure engineering and all. Mostly they are spending time on Terraform and Jenkins. Okay, so Jenkins will come under like a DevOps syllabus, right? I hope most of you learned Jenkins. Okay, so spend more time on Jenkins and Terraform, which will help you to get job easily. And if you know Ansible, it will be an added advantage for you. Okay, 30th one is Terraform format. Actually, why we need format is it will format configurations to ensure consistency. For example, if you are writing a code, but which is not in the Terraform standard while looking, okay. So if we execute Terraform FMT command, it will what it will do is it will format your code. So for ensure the consistency. Okay, so you can use this command. Okay, next one is validating Terraform configuration files. Okay, now where we are, think up to this is enough. After that we will have practical sessions. Okay, next is 14th one is validating Terraform config files. If actually since A is not working, it may not look well. Just wait. Let me update it. Yeah, now it good. Okay. What is the purpose of this? Actually, Terraform validate command checks the configuration syntax and logical errors. If there is any issues with your syntax or logical errors, okay, so it will let you know. If you execute Terraform, just an engine software which should be small. Terraform validate. VA validate. Okay, if you use this command, if there is any syntax issue or logical errors, it will let us know. Okay, this is enough while coming to theory, because last two class we have done theory only. So now we will focus on practical. Okay, like up to 4, we will focus on practical only today. Okay. Okay, we will discuss what and all we have learned, how what and all best practices we have to follow while writing code. Okay. Again, tomorrow will be theory class. Next class will be practical class. Okay. After one theory, one practical, like that it will go. Okay. Now, now theory ends. Now we will start practical. Okay. I hope last class itself I told, right, you should have an AWS account. Is anyone having AWS account? Who has AWS account? If you share,
Yeah, Kishore.
like you will get good hands-on experience. Okay, then can you share your screen so we can learn and we can implement all these things?
Sure, I will share the screen.
I'll guide, okay? You no need to
Yeah.
worry. I'll just guide you. So understand and do. You will get good answer. And
Yeah,
one
I
more
share
thing,
the screen.
yeah. One more thing is, like hereafter, while we are having practical sessions, don't terminate this. Okay. Now who is sharing screen? Madhu, I think. Okay. So
Yeah,
just don't terminate this. You can stop this. Okay. So what we can do is in next hands-on we can just carry forward with this. So you will also have good continuity. Okay.
okay.
Just give me a minute. I will share you the one link. Okay. Just give me a minute. So first we will first create one new server for Terraform. Just click EC2, or if you are having any existing servers also we can use. Okay, it will not take much memory. I think you don't have any instance, right? Just create one. Okay.
Yep.
Use Ubuntu. Okay, Ubuntu 22.04 version AM. Okay. And don't terminate this. Okay.
Okay. Which one? 24? 22, right?
22.04. Yeah. Okay.
Yeah.
Remaining and I'll go by default. No issues.
The network and remaining things default only, right?
Yeah, everything default. Just click launch instance.
Okay.
Others also please do it. Okay. Otherwise you will forget. Yeah. Now you have Visual Studio Code, right?
Yep.
Yeah, just connect this machine in Visual Studio Code. Do you know, or I need to guide?
No, I don't know that.
Okay, then I'll guide you. Just go to Visual Studio. Okay. Now in right side, not in right side, in left side, you can see, yeah, in that after extension, yeah, below that, yeah, Remote Explorer, you can see, right? Just click that. Okay. Now here SSH, you can able to see SSH, right? No, in the top, yeah, in the same line, you can see settings button, right? Just click that settings button. Now click that first file, .ssh config. Yeah, okay. Now line number 2 in host, give some name. Line number 2, I mean. Oh, no, not that one. Line number 2. That is line number 3, right?
Okay.
Just
Can I
give
remove
some name
alias
here.
or?
Yeah, you can remove that and give some name for your flexibility. Like Terraform, test, like that. Okay. Now just go to your AWS account and copy your public IP. And just replace that with in line number 3 in orange color. You can see host name, right? Yeah, just replace that with this. Okay, in user, just remove that and type Ubuntu. For others, I will let you know, okay, how to install this extension. You have already installed it. Okay, so I will guide you like how you can install if you are new to Visual Studio. Okay, so don't worry. Then click enter. Now in next line type capital I identify. Yeah, second one. Now space. You have that PEM file, right? That you have used. So just copy paste that path here. While creating instance, you choose one PEM file, right? Do you know that path?
No.
Then why you have chosen it? You can create new one, right?
Sorry,
If you
which
don't
one
know.
you want? This one?
No. Yeah, this server is there, right? You have used one PEM file, right? For this, just
Okay. That one. PEM file. I
yeah,
know. 1 minute.
yeah, you know. Then just go there. Yeah, keep here. Yeah, just copy the path of this. Paste slash. You have to mention your PEM file name also. Just copy paste from the nginx web server.pem is there, right? That is your name.
Yeah.
So just copy that name. You have to copy that name.
Yeah, I'm doing.
Click show. Yeah. Good. .pem also needed one. .pem. Okay. Now press Ctrl S.
Yes.
Okay. Now just you in the top like remote tunnel SSH you can able to see, right, in the left side. On that page you can see reload button, right? Just click that reload.
Yeah, I done.
Yeah. Okay. Now good. Now under SSH you can see test, right?
Yes.
Yeah, in the same line you can see one box with the plus symbol, right? You have to click that. Yeah. Click it. Now click Linux. Now click continue. This is the procedure. Okay, others also please listen and do it. Permission denied. Is that key is correct? Just go to your AWS account. I check whether you have used the correct key. So just is on. Wait. Just I'll take control of your screen for some time. Just accept it.
Yeah, done.
Okay, it's correct only. Nginx web server key name. Okay, you are getting permission issue. Just give me a minute. We will fix this.
Okay.
Do you have do you have Git bash?
No.
Okay. Just wait a minute. Okay. Okay, then open your PowerShell. I will share 2 commands. Okay, you execute because it will be fast for you. Okay, so since you are using Windows, this is the command. Okay, just paste this command in a notepad. I will let you know what you have to do. Yeah, in key name is there, right? Your key name. Just remove that. Wait. Just remove that your hyphen key key.pm and use the path of your pim file. Copy that from your notepad itself, like VS Code itself. Don't copy from here. Just copy from your VS Code itself. You have already done, right?
Is it fine?
Yeah, in second command also you have to do the same. I mean, like I have copy pasted the second command multiple times, I think. So one command is using
Okay.
enough. On last command, okay?
Yeah.
Yeah. Now execute this in your PowerShell one by one. Open just open your PowerShell and execute this.
Then
Okay, actually it is failing. Just copy paste that error in chat box. I'll check.
oh, yeah.
Okay, just okay. Just give me a minute. I'll just check why you are getting this permission issue. Okay. Now I will share one command. I just updated. Okay. So just copy paste this command directly.
Yeah.
It is processed, right? Now just go there.
Yes.
Just go to Visual Studio Code. Yeah. Now just click retry. Anyway, you close it. No issues. No issues. Just wait. Just wait. I'll do.
Yeah.
Actually, just close your Visual Studio Code and reopen it since you have updated permission. Close this also. Close this everything. Yeah. Now reopen this. Okay. Just wait. I'll open. Okay. Okay. Then what you can do is just go to that path. Okay. This is the path, right? Nginx. Where is that?
This one.
Yeah. Just wait. Just copy this. Where is your C?
C drive, right?
Yeah. Go to C. Yeah. Just go to Visual Studio. No. Visual Studio Code. Just go to the tab. Yeah. Wait. Let me go. Users. You can see this path, right?
Yeah,
.ssh config. Go to .ssh folder.
sure. One minute. Yeah.
Just paste it here. Let me paste. Okay. Now copy this path. Okay. Go to Visual Studio Code. Actually, I am going just wait. Okay. This is how in single chart you can paste. Okay. Identify. Just let me check one more time. User host name host. Okay. Okay, everything is good to go. It is connected successfully. It's due to permission issue. Okay, that we have fixed it now. Okay, now let me maximize this. Okay, this is our server. Okay, now let me open this server in okay, so this is our server. Okay, I just shared you one link in not like in chat box, right? Just go to your chat box. Okay, now what we are going to do is we are going to